Excuse me. Fix this filter for a second here. Hmm. All right. Let's see what's going on here. I do not have, for some reason. There we go. There's my big monitor. All right, throw this over here for you guys. Let's do a little bit of Linux systems administration today. So what this is going to look like, this is going to be a little talk that we did a while ago from the Professional Linux Users Group. And I just sometimes like to go through different talks that we have. And I had been working on this one for a while, but what I would highly advise is if anybody's following along with me, you have some kind of notepad, something like Notepad++, OneNote, LogSec, Obsidian. You could be doing just about anything you want. Just have something like that open so you can maybe grab some of the info out of there and take notes. I sometimes take notes while I'm going, but I also sometimes miss things because it's not as important for me to take notes. I kind of know the stuff. So let's talk about Linux systems administration for people that want to maybe get into this field. Maybe you want to understand this stuff a little better. Maybe you want to see what we do in the Professional Linux Users Group and kind of see what the gist of us working together and the things that we do are. So, all right. So some administration tasks, right? We've got lab portions to our courses and labs that you guys can get into. But what we try to do is get you to understand the tasks around maintaining a group of systems. You've got some servers, or some company you're working for has a bunch of servers, and your job is to keep that fleet of servers working, right? You're going to keep them working from a capacity standpoint. You're going to keep them working from a capability standpoint. Maybe you're adding software, removing software. You're doing security, whatever types of things you're doing. And there's all that. Never fear, dead end. How's it going, guys? We are. Yeah, this is completely different than the class. Yes, this is different than the Saturday stuff. All right. So one of the things you'd want to know how to do is how to power on or off a server. Let's say you hop into a server and the server is up. Maybe one thing you might need to check as an administrator is somebody tells you there's something wrong with the server, so you want to go see, is that server up? Has that server recently rebooted? A lot of changes happen when configurations are read as services are restarted that haven't been restarted in a long time. So that's kind of a thing to think about. Maintaining an inventory for a system, like what type of tool are you using for your inventory? In a system, you might have all types of tools. I may be, where am I at here? Hold on. I literally don't know what happened there. That was weird. I'll go back over here. Super weird. Whatever just happened to my system. But I may come over here and then on a system, I may have a way of looking at all the nodes that are available, and then a way to manage those systems. Maybe I have an inventory in Ansible, right? Maybe Ansible hosts are where I keep my inventory. Companies keep inventories in all kinds of different places. And one of your jobs as an administrator is going to be able to know how to find all the servers that are around. Like somebody may have an incomplete list online, like you may have documentation that's very outdated and new servers have been updated and they've moved to a newer set of naming standards and all these kind of things. So you need to know how to use your inventory. Now, in my system, if I were to use an example like this, I could just add hosts here. So I happen to have a system down here under maybe I just had maybe like support. And in there, I've got this other server that you might have noticed called Kafka. And maybe the support nodes don't fall into the Rocky or the Hammer nodes. They're just other nodes in my cluster, right? So maybe I do that, and then now I can see that as part of my inventory or whatever. I've got these support systems that I can hit. So you might need to know how to do that on as an administrator of a system. Obviously, changing or removing inventory, maybe you decommission a set of servers and you document it through whatever processes you have, and then you kind of go from there. Okay. Then it says installing and updating software, configuring repositories, configuring software to work within the cluster. You know, I may be over on this Rocky 19 box, and I may say DNF, you know, install maybe Calce. Maybe I want that Calce tool on my system. Maybe not, but maybe it's already installed. Or maybe I need to install like a newer version of something. Maybe I could check the repositories for updates. But where are those repositories configured, right? These are things that you're going to need to know. So etc yum.repos.d is where we tend to put them in Red Hat systems. And in here, we've got these definitions of repos. So maybe you've got these extra packages for enterprise Linux repos, and they just look like this. Here's the definition of a repo. It's got the square brackets around it for its name, and then it's got a actual name that would be given if you were to go read through, like if you were to do a DNF repo list. That's its name within the system. And then there's some things commented out just for us to see. There's a base URL over here. And then we should have right here, here's our link for where we would go download data. Is it enabled or not enabled? Is there a GPG check required for it? And if so, where is the GPG key at? So I should go be able to read that GPG key on the system and make sure that it's, you know, the correct one that was downloaded from wherever. And then I'm not sure what the count me is, but that's just some value in there. I could probably read the man pages on it to figure it out. But if I do a DNF repo list, right, I should see all the repos, right? And I see an EPEL or EPEL, it's extra packages for enterprise Linux, right? And I see that in there. But if I were to VI this file real quick, right? And I were to take this enabled and YYP, and let's just hit I real quick, and we'll pound that one out, and we'll make this one 0. So now it's enabled 0. And if I do that same DNF repo list, I no longer see that, right? So watch, I'll go put it back in. Oops. Enabled. There it is again. It's back. It's in the same spot it would have been before, but it was missing. So the repo lists are configured with a system when they first come, right? So there are the trusted repos that are out in the world, but almost universally, when you get bigger than maybe about 100 computers in a system, 100, I would even say less nowadays, but let's just say that you're some smaller company, maybe you'll trust those repos and you'll download stuff, and that's fine. But most of us, and this is going to be, I think, week 5 of the security course, we point to our internal repos. We build our own internal repos and we point to those. And we no longer pull anything that hasn't been vetted in our lower environments anymore. And we do that for security reasons. We do that for stability of our environment. We do that for stability and make sure that everything works the way that we expect it to. Okay. Sorry, I keep looking over here because I used to have my chat right above me here, but now I have it way over here on the side, so I got to go look over there. Actually, I can turn this monitor, though. So it's kind of nice. I can at least see it like it's looking at me. So, all right. So, you know, we do that. We can configure software. We can add software. So maybe Rocky 19 needs some package that it didn't have. And maybe I say RPM QA grep for maybe like bzip. Does it have bzip? It does have bzip. Does it have gzip? We have gzip. Okay. Might be a package that we might not have that might exist out there. Let's look for scap. I don't see any scap, but if I do a DNF search all, it's going to search all the repository metadata for scap. Anything with scap in it, which is the secure. Look at all the scap. Scap security guide, rule playbooks, scap security guide, doc no arch, bunch of stuff. In fact, I've got a customer that I have them installing this on because when I meet with them tomorrow, I'm going to show them how to build out the the playbook that you use to harden a box, right? I'm going to show them how to do that. You guys are going to do that maybe next week in the security course. Hold on, let me just pull up the security course. I know I have it. Hold on, let's just pull up because I don't remember where it is in the security course. Let's just pull up the security engineering syllabus. Let's go look at the syllabus real quick. Because I don't remember where it is. I would likely be making you do. What did I say we were going to be doing? Building the SCAP. Shoot, we'd probably have to do it sooner than later. Oh, I think we are doing it this week. Oh, we're going to have, like, the labs this week are going to be long. You guys aren't going to be happy with me this week. So, all right. So anyways, there's that. And Amber, how's it going over on the YouTube side of things? Yeah, we're just, we're working through talking about Linux systems administration, right? And then configuring software to work within the cluster. So maybe you have to install some of the software. And it's pretty simple nowadays for most software. I could just say SCAP Workbench, like just DNF install it, and it'll install it, and it'll give me, like if I do DNF install SCAP Workbench, should just go and grab all the dependencies for it, right? Look at that. It wants to install 222 packages and upgrade 3 to be able to install this one tool. I just told it to do this one tool. But it says, hey, you need to upgrade all these, and then here's all these other things we need to install. And I might say, well, do it, but without the weak dependencies, right? There's all these things that we can do. Also, there would be a download size of 142 megs. So maybe I go, you know what? I don't really want that right now. And in DNF on the non-enterprise side, like the free version of this is going to be things that it doesn't remember. But when you use an enterprise tool like DNF with Red Hat and you're paying for it, it actually saves every one of those you ever run in temp, so you can rerun them later. Amber, everything's going good for me. We're having fun over here. We're not working too hard. I'm pretty much done for the day. I had to travel a little bit for some work stuff. I had to go see a data center, and then I have to work with a customer. I had to work with a customer today to get them ready for some STIGs, and then I'll be doing more with them tomorrow. But let's talk about responding to incidents, right? So you have system level failures and system security incidents. So where do we find those, right? Well, we could just be crawling around on a system. We could just be watching something like varlog messages maybe. But that quickly becomes untenable across thousands of systems, right? So a lot of times, like system level failures, you're going to find them through your tooling. You're going to have tooling, and you're going to have things set on your systems like agents and different type of active configuration. So in my home lab, and actually I probably need to set this up for all of these. In my home lab, we have all these different, like Ranger, we have all these different configurations to know if a node is up, right? Is a node responding? How long has it been up? Are our connections out working, or are our connections out busted? Are we getting logging information, and then do we use these log pieces of information to send? Maybe there's triggers in here that send things out. So there's all these ways that you can kind of get secure system level failures, and you'll end up having to respond to them. So let's say a box like this, it reboots. What might you do? If you get a call in the middle of the night and your system's down, well, you want to know how to get to where that system is. So is it a physical machine, and you got to connect in through like an IPMI, and IPMI will then give you access. That's your IP management interface. If you have that configured, which you should, and then if you have it documented to know how to get there, you should be able to get to it and get almost to like a little web page. Actually, it should just be a web page and show you if the server's down, if there's a hard drive failure, something like that. If you have something like a virtual machine, you should be able to pop up the virtual machine system, and then you should be able to go, well, that was Rocky 19, and we just powered him off. So then I should be able to go here and watch that system boot and validate that it's coming up correctly, it's walking through the process. This is one of these things where to know what the process looks like, to know how a boot process with Pixie works, you have to have watched it before. So maybe you have to have done this in your test environment and rebooted a machine before and saw it come up good. Maybe you've upgraded systems and tested them down in your dev environment before you get to prod, and you've seen some of these errors, so you know what kind of things can happen. And you know that, like, maybe when a system reboots after patching, there's a possibility that the kernel didn't get, you install a new kernel and then you flip over to the new kernel. Sometimes it goes bad. Sometimes things go wrong. So you flip back to the original kernel, get the system back up and along, and then and sometimes you have to do that by going back to a snapshot or something like that. There's all kinds of ways to get back to a working system, and then you figure out what was wrong and you rerun your upgrade path, right? You redo your upgrade. And if that doesn't work again, or if there's some break because of a software dependency or something like that, then sometimes those sets of patches don't get to go into those sets of servers. And then you say, well, what do we do then? Well, if we're going to be opening too many security vulnerabilities, we start to think about mitigating factors, right? How do we mitigate the system so that, it's a web server, so then we make sure it's behind our WAF. We make sure our WAF is watching for certain types of headers and traffic that are not supposed to come in. And maybe we make sure that our web application firewall doesn't allow certain types of traffic through. Those could be some reasonable ways to mitigate things. And that may not even be a thing that we have to do at the Linux administration. That may be something more when you're like platform, you're running the whole platform and you're helping your dev teams and stuff, but it's still something to think about, right? So anyway, and then you got security incidents. What's a security incident? Well, security incident is anything that affects a system or attempts to affect a system. It doesn't even have to be successful. It's still an incident, even if it fails, across the CIA triad, which is confidentiality, integrity, and availability. It does not matter if it's internal and accidental or external and malicious or internal and malicious. Literally none of those things matter. If I walked down the street and dropped a bunch of national secrets out and they just flew around and everything flew right into directly into a national press person's hand and they published it immediately, it wouldn't matter if I did that on purpose or accident. The event would have still occurred. The confidentiality of the data would have been breached. Same thing with integrity. I tell you guys all the time, if you have, a bunch of LTO4 tapes and nobody can get them back anymore because you've moved your tape drive too far forward and you're up on like an LTO 789 system and you can't read LTO4 tapes anymore, it doesn't matter that you have LTO4 tapes. The integrity of that data is gone. There's no integrity to that data. You can't get it anymore, right? It's gone. And also that's an availability problem too, right? But let's say those tapes start to degrade over time and you can't read them anymore. That's integrity, right? So, all right. So anyway, so that's administration tasks. Those are some things that you do from the start, maybe. Let's go see if we can get back in there. All right, systems backup. Systems backup. So some administration tasks, right? There's kind of the big four, which are CPU, memory, disk, and network, in that order. Those are the four things that we look for in that order. And we want to understand how we observe those things. So how do we observe how many CPUs we have? Maybe I've never been to this box before. NPROC. I know that there's 2 processors in here. Well, do I know how much they're being utilized right now? Well, I can look at uptime as a quick and dirty and see that no, they are not. There's not a lot of wait for them. But I can also do something like IOStat-C and only see the CPU usage, and that's only going to show it the one slice right there where we look at it, and then we can look at it in longer intervals, like every 10 seconds or something, every 1 second for 10 seconds or something. We see our systems mostly sitting idle, right? But that's CPU. And then, there's a bunch of other things that we can do with CPU. There's a bunch of different, I like the tool ATOP, which kind of aggregates up every 10 minutes or so on your system and can tell you what was going on. It can also tell you disk usage and stuff. All of these tools tend to read on the back end SAR. So you have a SAR tool. By the way, IOStat, DNF what provides IOStat. And you'll see that they all come from the same tool package, which is Systat. Sorry, I know I'm not supposed to crunch these on stream anymore, but I still do. And that's what happens sometimes. All right, so it's reading the metadata. All right, so there's our IOStat. Also, this one other tool, SAR. SAR should run from there too. SAR's got its own tool. Okay. No, it comes from Systat as well. Yeah, there it is. Reason this is important to know is if the package is missing, then you know how to go get it. There's also there's A top, there's B top, there's H top. There's a whole bunch of tops. There's just regular top. Some people want regular top. So anyway, so that's the CPU, right? And then you can look at how CPU is being used in other way. Again, top will show you, and then you can hit C and it'll show it by CPU. I don't do a whole lot of like looking at CPU like this, but I mean, you could do that if you wanted to. You know, you can always go look at an individual process, PSEF. Maybe if I knew like Promtail was running, I can go look at Promtail and see information about it. Yeah, there's a bunch of different top type programs, right? So that's kind of like the CPU side of things, right? But mainly we want to know, is our CPU used? So IOStat's good for this. Is our CPU being used at 100%? Is it being used? And what we talk about here is utilization, saturation, and errors. We'll get to that here in a second. But let's go look at memory then. So where's our memory at? Memory is not... So your CPU is how fast your system thinks. A lot of people kind of think memory is that same thing. Memory is actually all the open paging and all the open information that the CPU can reference quickly, right? So it's anything that has been accessed and then is being held open in a place that's not resident back on disk, right? Or anything that's been calculated that isn't going to be staying in processing is going to go be dropped out in memory, right? So our memory is best seen typically through a tool called Free, but you can also see a bunch of other information. You can look at your memory directly, which is, this one's hard to look at, but proc meminfo, right? I'll just look it through more. And this is all the information you might want to know about the system. There's the memory total of this box. Here's how much free, here's how much is available. But again, that's very, very raw, right? So what I prefer to see it like is this, free-m. You can go all the way to gigs, but that tends to be a little too simple. Like that's, you know, you're using too wide of a brush there. Right, that has oversimplified the thing. So I like free-m. You can add a T to it to see totals. Give you total information. And then you might ask on this type of system, why don't we have swap? Like Linux always wants swap, but why don't we have swap on this box? This might help answer it a little bit. Looking at the system like this might help you guys answer it. But why aren't we using swap? Why is it irrelevant if we use swap on this box? Hey, Fractal Cat, how's it going? I'm barely looking over there. Hayes, you can't hear me right now? Oh, well that's not good. Hopefully you guys can hear me. Maybe it's just because Hayes is busy. Because he's earning his pay. What is nice, Amber? So nice is where we take a process and we make it have a lower priority against the CPU. I'm going to tell you that I've seen nice used in labs and messed with it and like I know what it is, but I've never seen it used professionally. I've never seen anybody like, oh, I'm going to nice that process and then everything's going to work good. No, most of the time what we do is anymore now, maybe 20 something years ago, but nowadays, like we don't really do. Let me show you like this. And this may be a philosophical difference from me and other people, but I'm going to tell you this way the industry does it. So look at these boxes here. We got an AWX server, Grafana server, Grafana 2. We got some prod, near prod Kubernetes and my Loki box. A server only does any more nowadays. I mean, look at all this was that maybe like 12. That's 20. That's 24 that are, or 25 that are on. And then there's another box. It's another 1, 2, 3, 4 that are on. So we've got, 60 nodes in my environment across the 4 systems, right? Yeah, probably close to 60, let's say. Each nowadays, and this isn't maybe, I guess I'll tell you the enterprise philosophy that I mostly run into is this. We make a server single use. A server doesn't have a web server and it's MySQL on it anymore. Those are layered. So there's a maybe Apache or HTTPD front end. There's a MySQL middle tier, and then maybe MySQL is the back end, and then there's an application server in between there. But there's 3 servers doing 3 distinct functions. So the concept of having to nice a process, much less common nowadays. I would say even to the point of I've never really used it professionally. So, I mean, I guess you could. I mean, I just think there's too much instability moving processes around like that. I think you'll get weird stuff that happens, and stay away from it. Go easy on me. I was a born Windows user. My grandpa was a Linux guy. Fractal Cat. I don't know how old your grandpa is, but I mean, it's to be fair. Linux has only been around since '92, so 91, 92. I don't know what you're saying. But over here, yeah, it's because TempFS. TempFS is all the file system is run in memory. And then all of this is remote. Yep, so TempFS is a memory-based FS. If we did like a man on TempFS, maybe we can't see it. Where would we find that? I'm trying to think of what would have TempFS in it. Maybe. Okay. Well, either way, if you go read about TempFS, it's just on the memory. Okay. All right. And then, so we can observe things, right? And we can observe any of these things, and that's what we're going to kind of do today as I'm kind of hanging out here and working on this stuff. If you guys wanted to, you could get in any killer Coda shell and do these along with me. It's perfectly, would be perfectly easy and acceptable. After we observe things, right, as admins, we have to do some observing of systems. I would advise doing that when the shit has not hit the fan, so you understand kind of what's there. By the way, I can also observe settings, right? sysctl -a grep for IPv4, and then maybe I want to number line that so I see how many there are. There's 315 of these settings around how IPv4 interacts with my kernel, right? And I can go look at them and I can go figure out what all these things mean if I wanted to. But I want to know how to do that now, so if anybody ever asks me or wants me to check the difference between a Rocky 19 box and a Rocky 18 box in this sense, I can do it, right? I can come here and then say grep maybe -i udp_mem, and then could I say that that is the same as on the Rocky box, because maybe there's a different behavior and we suspect that there's something different, and very quickly I can come in here and go, no, they're pretty much the same. That's probably within, it's definitely within one standard deviation if we were to go across all the systems, but it's probably, within the error of tolerance that it's not going to be related. And I wouldn't spend a whole lot of time with that then. But after we observe and do all these things, maybe we benchmark. Maybe we start to load a system up and see what happens if we go back to Rocky 19, right? And then we have stress on our system. DNF install stress. And then maybe now I can stress the system up a little bit and see how my system behaves. Maybe I have a web server or a database server and I stress the system up, and then I see if under high load, does the database stop accepting connections? Does the web server stop performing back-end queries the way that it should? Does, whatever things I want to test, whatever. And actually this is a big part of if you guys get into chaos engineering, which is a pretty fun little thing. But if you go, look at Rangers chaos engineering, look at that dog. You come over here and you go to maybe Gremlin. and they've got their own little cert. You can go get a cert for free from them on chaos engineering. And then it's like, well, what is chaos engineering? Chaos engineering is in an environment asking a question. Very much the scientific methodology. What would happen if I pulled this plug? What would happen if this piece of memory went bad? What would happen? And you go and you test them. And if you say, well, Scott, hold on, I want to know a good one of these, I would say this guy right here probably has one of the best curated lists I've found. So I'll link this to you guys. It's the Dastergon. That's the name of his. I don't know the guy. I don't know, I couldn't tell you who he was, but I can just tell you he's got a really good list of chaos engineering. And you say, well, what will chaos engineering get me? Like, what kind of money can I make off chaos engineering? Chaos engineering is the heart of site reliability engineering. So if you guys have heard this term, site reliability engineering, oh, hey, I don't want to be a Linux guy. I don't want to be a DevOps guy. I want to be a site reliability engineer. This is what you would go do. So. All right. So there's a bunch of stuff here for you guys to go look at. Again, probably hours and hours you can spend, but you could get ready to go take that free cert, and then you'd be ready to go from there. All right. Let's get this thing out of the way. Get back to our notes. Then when we're done benchmarking or verifying that things exist the way that we expect, we can tune them. We can change things. We can move systems in real time. We can do sysctl commands and change things. We can make persistent changes in either etc. No, we don't even need to do that. We can change them here, but I don't like to change things here. I tend to change them down in sysctl.d, and then I make my own. In this case, I think I made the 99 remediate. 98 remediate. These were the ones that I made for a bunch of stuff that we were fixing for security vulnerabilities and stuff, right? And then you could go read about what these things are. Oh, you want to know what the free? Hold on, I'll go grab it real quick. Hold on, I'll actually link it. Hold on, I didn't link it. Yeah, they got a free certification still. One of our guys went and got it the other day. Here it is right here. Yeah, if you go get that, let me know down in the Discord. Like, let me know in the certification channel, and I tend to make it worth people's while if they go and do that. I mean, I think it's good to have it on your resume anyways, right? But if, aside from that, I tend to like do something like a Humble Bundle or something, because I think that's a good little thing for you guys to do. Okay. Let me get my discussion back up. All right, so then we tune things. We want to tune in a lower environment. See how it's red and it says danger? Yeah. The danger is mitigated because we don't do it in prod. If you have to do it in prod, it's probably an emergency. You're probably already in an emergency change mode, and you're trying to get a system back into working. And even then, you're going to do an emergency change after the fact, typically, depending on the posture of your company. But for me, I would absolutely document the change, and that's why I like doing emergency change type things, because then I can document what I did, when I was asked to do it, how it was done, and what it mitigated. Was the outcome that the system was currently working, and do we need to continue monitoring it in the near future or whatever? John Jones, what extension? What are you talking over here? You talking about this one that like flips through everything, or are you talking which one? Yeah, so this is called Revolver Tabs. I think it's being deprecated, and Fractal Cow, you can do any job you want. All you gotta do is start working on find a path to get there, and I think you can absolutely do it. Yes. Jones, I would tell you, be careful. Not careful, but the Revolver Tabs that I use up there, they have a I think they're being deprecated, so I don't know that they're gonna. Yeah, that's called Revolver Tabs, and then you can. So I can. This is kind of cool. I can open it, and I can go into like the options, and I can change how these. So it's every 10 seconds it switches to all the ones that I have open, but I could make some sit longer. So I could be like, I really want people to know about the site. Whoops. I really want people to know about the site. I really want people to know about the 2 free books, which are still being worked on by the guys. But maybe this book is being updated in real time, so I hit reload. And every time we get back to that page, it'll reload. But maybe I don't want to reload Grafana because I want Grafana to just run. You have all kinds of power in Revolver tabs. It's a pretty good little tool. So, save. And then, by the way, you can change things and do all kinds of stuff. But yeah, Revolver tabs, that's what that is. It's a pretty good little tool. Pretty good little setup. Something to play with. So, all right. Yeah, it's you know, Jones, it's something I put in a lot of database server, not database. Brain's all mushy. I put in a lot of NOCs over the years, Network Operations Center, and it works well, like for monitoring stuff and doing all that kind of stuff. Also, did I get my? I think I got myself all jacked up over here. See if I can go to something like that. Yeah, that fixed me. I was looking all messed up in the thing. Okay, let me pull this back up. So let's talk about, as you're sitting on a system, you know, you're doing uptime and you're looking at the load of the system, and maybe you're doing free-m and you're looking at utilization of how used the system is, and maybe it's easier for you to see something like that with top, right? If you do M and you see that we're, you know, using a very small amount of the overall memory, and then, you know, how much are we using of whatever. And when we talk about utilization is always a number between 0 and 100%. You have utilized a certain percentage of a thing. You have utilized a certain amount of the CPU, right? How much CPU has been utilized and how much is sitting idle, right? Once you get to 100% utilization, meaning there's nothing idle anymore, then what happens? So I'm going to jump over here, Rocky 19. We're going to run stress -C4 timeout of 180. So for 30 seconds, we're going to run. And now we're going to watch the IO stat here and see how much of the system is no longer idle. Look, we are hammering this box. He is not idle at all anymore. Well, once you get to 100% utilization of a system, once you get between 0 and 100%, you get all the way up utilized. The next process that wants to do anything on this box has a wait time, has a queue, right? As we, you know, queue is the non-American way of saying a line, right? You wait in a queue. It's a line to us, right? In America, we'd call it a queue, right? So once you get to saturation, there's a queue that forms. And as you wait for resources, if you start to time out, because after 5 minutes of not responding to an API, that far side connection is going to close, then we start to get errors. Couldn't connect, got a 404. Couldn't connect, got a 500, right? And you need to know the difference between I'm constantly telling you guys, you need to know the difference between the types of web errors, because even though you're just a Linux engineer, you're probably going to touch all of those different, I touch all that different crap all the time. So utilization, saturation, error, the use methodology, very easy to remember. How is the system being used, right? That could help you key in and remember this. Okay. All right. So anyways, I'm sorry I'm not watching chat too much either, but watch, when this gets done, we're going to see the utilization drop from 98%, 99% to 0, because then the utilization's down. And the next process, the next thing should be able to allocate, right? So we're going to look at some observation tools here. These will do, again, back to that observing, benchmarking, and tuning. We're going to look at some of the different tools. So observation tools, when this is done, we're using IOStat-1 right now, or -C1 right now. So it's doing only the CPU, not the devices. And it's doing it every 1 second for forever until we hit Control-C. We're going to wait on it real quick. So we're going to wait for this to run. Ramesh said, hello, any ideas about the Oracle Cloud Security breach? No, I haven't read anything about it. I've been doing, what was I doing today? I had to go to a data center, didn't get access, so I have to try again tomorrow. They put in all my requests, so that should be good. I went to a facility to get a new common access card, a CAC card. I can't say the word because if I say a CAC card, this thing thinks I'm saying cock and it won't say it. No, that did say it. That thing won't say the other words normally, see? Anyways, I couldn't get in there, so then I came back and then I went to lunch with some of the guys. So I haven't looked at anything. Also, I was on a call with one of our customers about showing them some security stuff. So I've been kind of busy with that. Oh, look, here it dropped. Utilization is 0 again. Do you guys see that? So let's look at some commands here. By the way, if you can get to a terminal, you could do some of these things with me. But one of the things I've been showing you guys quite a bit is uptime. So I'm going to do an uptime real quick, and I'm going to explain by looking over here. It shows when the system was last booted, and then it shows probably my favorite thing. Like I always check uptime on a system when I first get to it. It shows right here a load average. And that load average over here is 1, 5, and 15 minutes as a sliding window against the system, respectively. So the system just stopped processing at 100% load recently. The 1 minute sliding window is about to slide off and be at the lowest utilization. You're about to see that first number drop to pretty much 0. The middle number is a 5-minute window, and we were running that thing for 3 minutes. So there's going to be a long tail on that middle dropping because that middle is slowly going to drop down. And then that 15-minute window, we were only running 3 minutes of that 15-minute window. That's going to take a real long time to trail off because it's going to have a longer memory of that little 3-minute incident, if that kind of makes sense. So, yeah, Amber, I ran a stress-C4 over here. And then -T180, which is the time. So it's stress-C4, which means 4 CPUs, but I only have 2 CPUs in the box. So I stressed him harder than he should because he only got 2 CPUs. So it's stress-C4-T100, 180. There you go. Now you're going to watch this left one go down faster. The middle one's going to go down the slowest. And then the right one, again, has a longer memory of that, and it's going to drop off as well. All right. Thanks for the follow, Bonafide Englishman. Hopefully this is your cup of tea. Hopefully this is something that's useful to you. I appreciate you coming by. We are just doing Linux Systems Administration today. I'm doing it very light. We have a course that we run that's free in our Discord, and that one digs into Linux Systems Administration as it kind of applies within a business. This is just the act of being a Linux Systems Administrator, right? So for people who got here later, we started off with administration tasks that you might need to know. We talked about how we observe, benchmark, and tune things. Then we talked about utilization, saturation, and errors. And then now we're in our tools. We're watching our tools and we're seeing how they behave in a system. Yeah, Bonafide Englishman, we do. I would say it's a very small community of people. I mean, we only have about 4,800 people here. We got about 3,800 almost down in Discord. And I think there's a lot more tech focus coming from the YouTube side. So, yeah, no, but you're welcome to hang out. And we just kind of hang out. And yeah, we have, I don't know, almost 3,800 down in Discord, which is, you know, a mid-sized Linux type group, but we're bigger than some of the distros, so that's kind of cool. But anyways, yeah, this is what we do. We show people the stated goal of the group is to show you guys, if any of you are amateurs in this space or you are a hobbyist Linux person that does it for fun, we want to help you do it professionally. We want to get you guys into this space where you're working side by side with me and others and doing this stuff for real. And I think you can have, you know, some of you guys can have like a trajectory shift in your career because some of this stuff is very valuable. Voice over IP engineer, nice. Yeah. We actually, one of my good former college student of mine and good buddy of mine, he's a voice over IP guy out here in Phoenix area. So, Fractal Cal, you want to learn NeoVim? I'll tell you what, you will never see me tell everybody that they need to learn NeoVim. I think knowing your tools are good, knowing how to use your tools well are good, but I will never tell somebody how they have to do their administration, right? Zenochez, that's what we do, man. Over on the YouTube side, you don't. Everybody's a noob at something, right? Even I'm a noob. I've just been doing this stuff a long time. Other stuff, I got to learn how to do it all the time. So we know how to use Uptime. Uptime's pretty straightforward, but don't sleep on Uptime. If you called me out in the middle of the night and said, "Hey, Scott, the Rocky 19 server isn't working right," I promise you, the first thing I would do is try to log in, do an Uptime on it. Those are the two things I would always do. The other things I would do, always type last more to see who's logged in. Right? That's a see who's logged in. See, was it a reboot or was it like a crash? Does the system know what happened to it? And these are the things to kind of know. All right. Bonafide Englishman, thank you for the subscription. You don't have to watch any ads, so that's awesome. And then for us, it gives us people motivation to stick around and all that good stuff. But yeah, you're definitely welcome to hang out. The Discord, did somebody link the Discord for him? Discord's free. You can hang out down there. Lots and lots of stuff going on. We're running a systems admin course for people, again, for free down in there. And we're running a security engineering course, which I think people are enjoying as well. I think we got about 120 on the sysadmin and about 90 right now on the security engineering course. So lots and lots of work. Yeah. Fractal Cow, I'll tell you, I use VI. I use Vim if it's on a system, but I don't know all the new magic. I know all the old magic. So you will find, Fractal Cal, let me tell you I've been an engineer for a long time. I know this 100% for sure from having worked with thousands of engineers. I'm the most vanilla engineer you will ever meet. I don't even set up aliases. In fact, there's only one thing that I insist on putting on a system. There's only one thing I insist on putting on a system, and that's when I use my screen. I have a screen file that I use. Huh. Thought I had it in here. Oh, it's in my home. It's the only file that I really try to make sure I have somewhere, and it's because it makes my screen work so nice. Does that little thing across the bottom of my screen. That's the only reason I don't. I will use the aliases that come with a machine, Fractal Cow. That's it. Yeah. I mostly just, I use VI and Vim and... No, I have whatever aliases are here. That's it. All right. But anyway, so we're looking at a system. Those are the things I will always do. If you call me out in the middle of the night and say, "Hey, Scott, I need you to get on because, one of your junior guys is struggling," or hey, he asked for you to get on to work on a set of systems, I probably have never been on the systems either, right? We got a team of guys or something. I've probably never been there either. But the things I'm going to do for sure is see if that system's rebooted recently, because that makes me go look different places. And then I look who was logged in. Because I can't tell you how many times over the years, it's definitely over 10 times over the years that, I'll be on, and there'll be 10 people from a dev team, and they'll all be like, yeah, our server's down, and we don't know why. And I'll be like, were you guys using your server? They'll be like, no, we weren't, nope, we got here. I'm like, why are you all up right now? It's like the middle of the night. Anyways, literally, this happens so many times, it's like a trope for me. And then I say, hey, well... were any of you guys on the server? And they're like, no. We were just checking the server out. We didn't do anything. And I'm like, definitely all of you were logged in, and then the server crashed. Did anybody here ever see The Princess Bride? It's one of my favorite quotes for this. It's, "We are men of action. Lies do not become us." As an engineer, though, it doesn't help to hide the truth. I'm going to find the truth eventually. And if I don't find the truth, I'm just going to be as confused as you guys are. So we might as well start down here on the path to the truth, then way over here where you guys are like, no, none of us were on the system. Totally confused. And it's like the six-fingered man saying, "Let us get you to your boat." And he's like, I know I'm not going to my boat. I know I'm going to be fucking tortured. We are men of action. Lies do not become. And that's funny because I saw that as a kid, and it never, that line always resonated with me, but it didn't really trigger to me until I was an infantryman many years later, combat infantryman. It's 100% true. So. All right. Yeah, what changed? Nothing. All right, anyway, so let's go to more. Let's keep going. We've got other tools, But let's say this didn't have, so how would we know? We could just do vmstat. We can always just call a command by name. But what if it wasn't there? What if you went to a box and vmstat wasn't there? How would we know? I was showing you guys earlier. Maybe we do a which vmstat and we see, well, it is there, so that's good. But maybe we knew vmstat was on the box, but it wasn't in a path. Maybe we look at our path and see, well, why doesn't my path have the path to get to, oh, wait, shoot, somebody built it in their own home directory. And for me, I would literally just add their home directory to my path or whatever the path is, right? I'm not messing around. I just want to get back to sleep, right? In my example where I'm working over the weekend, I just want to get back to sleep. I don't want to be doing this Linux stuff anymore. So maybe with observation tools, we, maybe vmstat, I could do something like DNF what provides vmstat. That may help me find that it came from that same. Oh, this came from a different tool, proc ps-ng. I don't even know what that is. That's some system monitoring and utilities. So if that's not on a box, you may have to add it. But should you add that to a production system? I wouldn't, right? Like, I would not just add something like that willy-nilly. Maybe there's a reason it shouldn't be there. It's vmstat, S-T-A-T. If my system is saying it wrong, I apologize down here, but it's vmstat, S-T-A-T. So what other ways might we find it? We might be able to go, well, no, that might not work. I was going to say, no, that would probably take too long. We could do an RPM QA and then grab everything, but that would probably take too long. If we knew that it was in that proc tool, RPM-QL proc ps-ng, and maybe that would show us that vmstat was there. But then if for QL to work, what you might say, well, what the hell's a QL? QL will show you inside of an RPM called proc ps-ng, which was added to my system in some way. These are all the files that were added. QL will show you every file that was ever came from that tool. So if you suspected that two files were in conflict in some way, you could use QL and diff to find if they were there, if that makes sense. And then you say, well, when did this get installed? I don't know, RPM-QI for that proc ps-ng. And now I can see, it was installed Friday, June 7th. That was my birthday. I was going to say it was my birthday last year, but it's my birthday every year. So, but this would show me if I suspected some problem with vmstat as a tool. Well, it definitely hasn't changed in the last almost a year, right? I mean, that's been a year now. Well, not quite a year, but a while. It tells me what it does, tells me where it came from, tell me where we downloaded it, and what the URL was, like all these pieces of information. RPM keeps a tremendous amount of information about the system. Now, do you need to, here's, by the way, here's the history of all the things I've done today so far, if anybody needs it. Do you guys want me to throw that in my notes? And then I'll drop them here. I'll drop them in my notes, and then I'll put them at the end of the stream. I'll drop them in the, I'll clean them up and drop them in the Discord in our meeting notes. Does that work for you guys? Then you guys can just go in Discord and grab them all. So what is vmstat showing us? Let's look at vmstat. Let's play a game like we did earlier. Vmstat dash, we'll just do a 1 again. So 1 will be every 1 second in perpetuity. That's kind of cool looking. We could make it a little nicer maybe, and it'll lay out a little nicer. But that's about as good we're going to get. And then over here, we see what the things are doing. It tells us R is the number of processes running. The value greater than CPU count is called saturation, right? We're starting, if we get a number here greater than 2, right? We had that number, number of processor 2. If we get a number greater than 2, we're getting saturation waiting on CPU. So the vmstat command is telling us about that. Okay. Then, by the way, it shows the header every time you get to the bottom of the terminal, so it's kind of a smart command. Let's leave that running. Let's pop over here, we're still in there. And let's run a slightly smaller C and a slightly higher mem, but let's learn a little bit about stress real quick. There's a memory number of workers that we're going to spawn, and then there's the number of bytes per worker, which is a default of 256. So we have a free dash M. We see that we have enough to spawn approximately 5 of these, right? So let's do our stress command. Let's make that a 2, and we'll do a dash M, and we'll spawn 5 of these. And that should work without breaking because it's going to be under the amount of free mem that we had, right? So that should run. Over here, we should immediately see more and more of our system being used right here. So look, here's our threads that are waiting for CPU right here. See them? Over here, we see that we have less free memory than we did that's right when it started, right there. We have less free memory than we did. And when this goes to basically clear, we're going to have cleared all of that problem or that incident. Now, a lot of this stuff, so there's a concept here in engineering called load testing and stress testing. Does anybody know the difference between a load test and a stress test? The activity to kick off a load test and the activity to kick off a stress test are exactly the same. But does anybody know the difference between a load test and a stress test from an engineer's standpoint? I learned this from an aircraft engineer that was a buddy of mine. And I'm like, that's actually pretty cool. Not failover, but that's good. It's a good guess. I'm going to go real quick, guys. Hold on. Let me go to my streaming. I'll turn off my camera for 1 second. I'm going to pull up my hourglass. And I'm going to pull up a quick little hourglass here for a break. I like what you're saying, Twisted. So break, and then what is the difference between a load and a stress test? All right, I'm gonna take a real quick break. I'm gonna walk around for a second. What's the difference between yeah, Twisted Seed, you're exactly right. But there's one thing that I want you to say that changes something. But you're exactly right about the difference. But there's one other thing I need you to say for it to be completely accurate. All right, we'll walk for a minute. I'll be right back, guys. That's exactly right, Twisted Seed. That's exactly right. To be a stress test, you must break something. They will do exactly the same thing, but to be a stress test, you must break something. Otherwise, you just validated load. That's all you did. So you're correct. Yep, stress test and a load test are the same exact general behavior. Got a monster here. All right, we're still on break, but you guys are watching me drink a monster now. No, Amber, but here's the thing. A stress test and a load test could be of an airplane part. It could be of a rope. A stress test must break something. Otherwise, you just validated that it can handle the load. So if we do a stress test and I go like this and I pull a rope as hard as I can, and this hand goes free right here, it's popped off. That was what was broken in the stress. So I go again, this one pops off. Now I find that there's a weakness in the coupling of my hands, and when I do this, I need to now wear straps on my hands so I don't let go. It's just an example. But if, however, I pull like this, and as much as I can pull and as much load as I can put on the system, I never break anything, it's just a load test. We validated the load of the system. That's all. That's the difference. So I guess all the Starlink Twisted. I don't have Starlink. I think my brother John does, because he's way up in like northern Indiana. He's so far in northern Indiana, northern Idaho, that he is basically in Canada. My brother's so far up there. By the way, did this system? Oh, the system cleaned up. Look, he finished. He finished his little test. I'm gonna start a new one that'll finish right around the end of our break. So we'll go 24, right? Because that'll be right at the end of our break. So you can watch him load the system back up over here. All right, I'm gonna finish my break without my camera on. You guys talk amongst yourselves, take a break, take a walk. We're on break. Check on Ranger while we're on break here. How's Ranger doing? How's Ranger doing? That dog has not moved. I am almost slightly worried for him, but no, he's all right. When he really is out, he crosses his paws. He kind of looks like he's got his paws crossed right there. When he was younger dog, he would sometimes run in his sleep, and it was super cute. Like, I'm sure Ranger's, big old tough dog. He doesn't want to be called cute, but he can definitely, he does all right. Fractal Cow, take a break. Then you won't feel. Yeah, a good load test will tend to turn into a stress test, and if you're keeping track of things, you'll find where the thing broke. So that's actually a good point. Yeah, but people will often use interchangeably the term stress and load test, but they start out the same, but they have different end points and end games. And if you can't successfully stress the system, you just tested the load. So, yeah, we love that little Ranger dog. We love Ranger. He's a good dog. We'll keep an eye on him while this system gets beat up over here. By the way, I could go over here. I could stop this. I could run it with more of these and actually break the system over here. This is going to use all of them, and then it's going to break. It actually broke. It couldn't allocate all of them. So maybe at like 8. It might. Nope, didn't make it to 8. I think 6 would probably even be too high. The Ranger down there looking around. Yeah, that's getting closer to full utilization. Yeah, we might be able to get one more in there. Let's try 7. It's gonna look like it's getting real low. It's getting real low on that. Oh, it broke. See? So 6 is our max. Because there wasn't enough to allocate and it broke right there. Right there is where it broke. So we can figure out a lot of stuff about our systems, guys. We got a lot of tools to dig in. I think I've shown you guys this before, but there's a guy. I think his name is Brendan. Yeah, this guy. He's probably, I'm gonna link you guys. He's probably one of the best sites on the web for just. Hey, Runamucker, how's it going? He's probably one of the best sites on the web for all the commands. Like, look at all these different commands to like dig in and look at this system. Here's all the. I mean, look, this is way more than I could talk about in one day. And you can just go play them. It's all observability, so you're not breaking anything. You're just observing your system, right? All right, I'll pull myself back up here. Anyways, look at all these tools here. Look how systems are happening. NetStat, SS, all these tools. And then and then when you're done with that, you're like, oh, does he got all kinds of other tools? Oh, sure he does. Static performance testing. Let me get out of here. Performance benchmarking. Different tools that you might use. Look at all that. So many things to go play around with and get better at. If you want to get into the business of looking at how a system works, right? Like you got all kinds of tools, guys. All kinds of things to do. All kinds of things to get in there. Yeah, Runamucker, with some of these tools, I often describe Linux systems like a ship, and you build the ship and then you push it off into the night. And to Runamucker's point about computer science and what tools should I use, you're pushing this thing off into the night and you rev up the engine, right? You do like a perf test like I just did that revs up the engine of our boat, but then you've got this like little microscope, and you're looking at like one little thing over here to see if the pressure gauge goes high. And if the pressure gauge doesn't go high with that one tool, you go, well, I conclude that the system was not under heavy load. It's not true. Fucking the engine was over here spinning. We were beating the shit out of this thing. We were going 100 knots through the water, right? We were moving. But you were just looking at this one thing as a test. And, because the fridge didn't go above 32 degrees, you think that everything. So, yeah, so to that point is like you have to use your tools well. And this is one of the things I tell you guys as sysadmins, don't try to figure out your tool in the heat of battle. You got called out in the middle of the night. You better know some tools. You better know some things about, is the system up? Is it running? Is the software? These are all these admin things that I'm always showing you guys. Like, is the service starting? Why isn't the service starting? Service isn't starting because the back-end storage isn't there. Why isn't the back-end storage there? Well, because in the boot up process, it busted. Can I just mount it now? Was there a timing issue? Do we got to fix that Monday morning? Let's get this system back on the road, doing what it should do. Note the problems, and we can go in and worry about the fixes later if it's a relatively stable system. If this is the second or third time it's happened this weekend, well, now we obviously have some other thing we need to figure out. But my point is, we need to know how to use our tools when we get there. We don't want to be trying to figure out how to fight in the middle of a fight. That's not a good way to do things. So, Fractal Cow, you want to help people with Windows? Well, I mean, you can do that. Nothing wrong with that. Yeah, Twisted Seed. There's a lot of info on that graph. I don't know all those tools on that graph. I know the ones that I'm good at, but I would probably go there if I wanted to add some more to my tool belt. Yeah. Which, by the way, one of the reasons I like doing this Linux sysadmin stuff with you guys is we work through and we figure stuff out, find more and more stuff. So, so we were on VMstat. Now let's go to MPstat. So, what does MPstat do? Where do we get it? MPstat 1. Looks like this is going to show me what is going on with all my processors, right? And it shows it per CPU breakdown. So in my case, I only see the total, right? I'm only seeing a total. So I might need to do like a -P, -P, all in every 1 second, and now it'll show me all 0 and 1. Now we know we have 2 CPUs, so we're getting an aggregate and then each one. And you might say, well, why would this be useful? Can anybody? Let's stop it on here. Let's go real quick to. Let's go to a box. Let's look at this guy real quick. We could leave it running over here. It doesn't really hurt. But let's go here to Llama. We've got this Llama box. Oh, did I turn him off? Let's see who else is on. I turned him off last night because he wasn't doing anything. Let's go to. Who exists? Oh, Moodle's on. All right. MP stats there. So this guy's got how many CPUs? You can see that pretty quick. 4, right? Does everybody agree that I've got 4 CPUs right here? Hey, Colcus, how's it going? We're just doing some sysadmin stuff that's not directly in any of the courses, but stuff that I think is good. So, check this out. You're working with a dev team. Dev team is having a problem, and one of their developers is like, well, on this branch, I'm 100% sure. You know, we've done a code review, and maybe you're not a coder. I'm not a coder. I don't do that stuff professionally. I can help out, and I can do code reviews, but I don't claim to be any software engineer that's shipped any software, right? Check it out real quick. Yeah, we've got these 4 processors. One of our senior developers insists that on his branch and on the version that's running on the system of his code, he's got it very much hyper-threaded. So you come over here, right? And you start running this. So now he starts running his application that he insists is hyper-threaded across all the cores. And this is what you see right here. Now, we don't have to go into engineering with our fucking dukes up like it's 1930 style boxing. We don't have to fist fight another engineer. But guys, is that thing using all 4 cores? Or is it actually only touching 2 cores right now? By the way, we don't have to argue with anybody. I tell you guys this all the time as an engineer. I don't have to fucking argue with anybody. I got the facts right here. It's only touching 2 cores. So, I don't have to call him stupid. I don't have to tell him that he's definitely got something wrong. But I might just leave this up while we're having our discussion and go, well, this is what my server's seeing. Am I on the right server? Well, it's the Moodle server we're testing on, right? Is that where we're at, guys? Yeah? Yeah, so here's the thing. I tell you guys this about engineering all the time. We are searching for truth. We don't have to be angry about it. We don't have to yell at other engineers. I mean, if they're going to sit around, if everybody in the room is going to look at this and go, oh, Scott, it's definitely your Linux box, then I'd be like, all right. I guess we're not going to fix it on this call. Make sure I'm going to bill you guys for this, and then we'll talk tomorrow, I guess. Right? So, clearly I'm not on the right. I've been on the wrong server. I've been called out, and the ticket, when I get called out, the ticket will say, something Node 03, so I'll go to Node 03, and I'll be like, guys, this server looks good. And they're like, oh, no, sorry, it's Node 02. And you're like, going to be one of these nights. It happens. But this is why I say, open kimono, which is just the idea that I don't have any weapons here in my kimono. It's not that you're showing them all your weapons, I guess. But the point is, I can just show that, and then I can see that it's not, yeah, they sent me to the wrong node. They did this. Tiago, all the stuff I do is free. Yeah. I have one book on LeanPub, but no, everything in the Discord, everything on YouTube, all the stuff's free. Yeah. Yeah. But look how I can see what's going on in my system. What did I do? Over here on stress, I just used C2, so I knew it was going to hit 2 cores. And then I can see right here, it just happened to pick the 1 and the 2 core. This becomes, in high-performance compute, I've told some of you guys this before, and some of you guys are probably going to be like, I never heard Scott talk about this before. In high-performance compute, we almost universally take that 0 core and use it for Slurm. Slurm in the system, right? So 0, Sorry, we leave 0 for the system. We let the system run on 0 on the first core of a box. And then nowadays, so this is a weird one. By the way, this has been weird for my team because we only started dealing with this maybe in September of last year. We use a tool called Weka. You guys all heard about Weka? So Weka is this high-speed file system, and it spins up all of these. It spins up these containers on your boxes, and then it locks to the first 4 CPUs by default. So 0 is gone, 1, 2, 3, and 4 are gone. 5 cores out of your system. Well, I'm routinely dealing with servers with 256 cores, right? maybe even bigger sometimes, but let's say 256 right now for a liquid cooled system. Now I've lost 5. Now all of my Slurm allocations against those boxes, if I'm running jobs, are only against 251 cores. Well, you say, why does that matter, Scott? Well, this is why it matters. Because nproc free-m, we have about 16 gigs of RAM on this box, and we have 4 cores. So if we were doing the calculations for like OpenMPI or something like that, we have 4 CPUs and 16 gigs of RAM. So we have 1 CPU for every 4 gigs of RAM. That's a pretty good ratio on a high-performance compute box in a what we call like a supercomputer or a cluster. But if I have 5 of these, I have 5 of these allocated already to some other thing, so I only have 251, that might change the memory totals on my boxes. So now I have to do some different calculations. My speed tests are going to change. The way that I load test and do what are called LinPack runs are going to change because the ratio of number of CPUs to overall number of RAM is different. So we may even shave off some of the RAM and not use it. You say, really? To keep the ratio the same is better across all your systems than to have systems that are changing. It's a nightmare. Nightmare if things are different. We want all the things to be the same. We want to look down the row and see everything the same in a compute cluster, always. So anyways, I showed you guys all that to show you that, like, you got a lot of power, you got a lot of tools here, and this is just one more tool. So this was MPStat. If we did the same exercises we did earlier with MPStat, I know I made it a little smaller, but we'll stop it. What will we do? Which MPStat? Where is MPStat? We might say what DNF, what provides MPStat. I think this is also, we're getting a little bit of a problem, but that's fine. It doesn't matter. URL lib3 is just a URL library that's common for Python 3. I actually use that in I got a tool that I use that in. Oh, it comes from Syststat. Yep, there it is, Syststat right there. So, how do you generalize? Oh, so if you can configure. So what happens is there's a tool called Slurm. So let's back up a second. You've got a supercomputer that's 1,000 systems, right? They are all going to respond to one node's going to be in charge. That's typically your Slurm control daemon, your Slurm controller. And that node will, oh, hold on a second. I got to fix something. That's something I got to fix right now. Hold on. Notepad. Give me a second. Give me a second here, guys. File open. Oh! Thank you for the bits, Hector. Hopefully this stuff's useful to you. Give me 1 second real quick. And I don't do anything with LeetCode, so I can't help you guys with that. My ticker info is wrong. This should be 3,700. There we go. File. Save. Transition. Boom, that should say 3,700 now. I was like, wait, why does it say 3,600? MPStat. I could do RPM-QL against Syststat. Grep for MPStat. See that there's my MPStat. I could even maybe be kind of sneaky and say, well, what are all the tools that Syststat brought to the system? And maybe I look for user bin like that. And then now I see these are all the cool things that came from Syststat as I put Syststat on the system. Sifs IOstat, I don't even know what all that is. IOstat, MPStat, PIDstat. We're going to look at PIDstat. SADF, I don't even know what SADF is. That might be kind of fun. How would I learn them? I would go read the man pages on them. I don't even know what SADF is. Oh, so you can read the contents of data files created by SAR. Okay, so you use SAR. And SAR can write out to like CSV. So that's actually really nice. I didn't know about that tool, but it can write out to CSV. If I can write to CSV, I can feed management, right? We talk about how management always wants to see stuff in CSV format so they can open it in Excel. Boom, there we go. Yeah, Fractal, you're always welcome to hang out, man. That's you know, we're here to show you that you guys can do this stuff professionally if you want. All of us, like if you've listened to me for more than 5 minutes, you probably do this stuff at least as an amateur, right? At least you play with this stuff, you know, hobbyist type stuff. But if you want to be a pro, this is what we do around here. We show you guys how to be a professional. So, all right, let's keep going. So observation tools, MP stat. Then we looked at, you know, we were just messing. We're just seeing what we could see. What can we pull out of the system? What can it tell us? So now let's do PID stat. So PID stat, PID stat dash L, I think. Yep. It might be dash 1. Oh, it is dash L 1. So every 1 second, what processes are being used against and against what CPU? So maybe I can see here that stress command is still over here running, and that timeout should be, I would think that's almost done. It's been 10 minutes, right? But I can see that stress is running those systems. I can also see the process ID of one of these, right? So maybe I want to know a little more about the system now. So then maybe I control C and I do ps-ef grep for that process ID. And I see that, oh, it's, nope, it's gone. Yeah, it's gone. It's all done. Let's go back over here. Finally finished, right as we were trying to get into it. So let's go find another one of these. Okay. Boom. And then now this is the command that's doing that. Then you say, well, what process, like LSOF-P for the processes, what files is that using? These are the files, right? And then I can do like a stress, and then what is it? I could do not stress, strace. strace should allow us to follow, right? Or actually look at the initial. So we could look at the PID dash attach. So we could do stress dash P. There's our PID again. And we can just look at what's going on with inside of that. If there's anything that's happening. Maybe strace isn't great. Maybe ltrace is better, right? Because ltrace is going to show us. Oh, we don't have ltrace. Ltrace is going to show us the libraries as opposed to the processes that it's running against and the things that it's doing with system calls. So, Amber, we have a couple of ways. We have a. I mean, if you're on YouTube, I don't know of a good way. I guess I have a. Like we've got a Discord that people can contribute to. You know. I don't ask for any of that kind of stuff, but if people want to, we've got, did I say Discord? No. We've got a GitHub. GitHub's one way. We have, probably the easiest way. I set it up the other day because the guys kept getting on me about not being able to take donations or whatever. We have a little shop. I've been putting the shop together, so it's not very good yet. We do have a little shop though, right? If anybody wants anything. There's cool little shop stuff. My wife likes the cat, so that's why I made the little, what? Oh, I got this thing on. Hold on. I got to turn off this zero trust. I'm using a customer's VPN and it locks me out so I can't see my shirt or my beanie. My wife likes that cat. But anyways, I don't know. You know, that's something that's a way to support us and get yourself cool stuff, I guess. But yeah, I don't sit around and ask for that too much because, you know, I don't want to inundate people with that kind of stuff, but that is something that's there for you guys. All right, let's go over here. Let's get back on this because we can use PIDstat to see. Oh, this is a great example because it's showing Java. Look in Java, bane of my existence, man. I've had so many Java developers over the years that I've had to try to help everything do anything. Jake Caspian, hopefully this stuff's useful to you. Yeah, if you've never been on Twitch before, this is it. You know, it's this, and it's like, I don't know, just chatting streams and people arguing about video games mostly. I'm one of the only guys I think on Twitch that's trying to teach anybody anything, but I don't know. There's some other ones, I guess, but most people are trying to like entertain people and stuff. Um, Atticus, I definitely need to make make more merch, but it does send to UK. I don't know. I think there's some shipping involved. I don't know. So the GitHub is, hold on. I'll link the GitHub for people that want it. Although, I don't do a whole lot of guys, you got to remember, I'm just a Linux engineer, so like my GitHub stuff's not great. So I do have some cool stuff on there, like I show you guys how to build bastions, and then all of our labs are in there and stuff. But we also have the other one that people have been contributing to, which is the we got the professional Linux users group one. So Fractal Cow, you want to contribute to open source? Well, what you do is you find a project. I'll show you. Let's say Fractal Cow, let's say you wanted to, let's find a good one for you. Let's say that you were like, hey, I really want to learn, or I really want to work on, let's say open source, I don't know, let's just say that you wanted to work on like open source drawing, right? And there's a really good open source tool out there called Excalidraw. I don't know if it'll even show up on here, but let's go Excalidraw. A lot of people don't know that that's actually open source. And you can go to GitHub.io for Excalidraw. And then this is how I would get involved if I wanted to. Back in the day, you would go to sourceforge.net. Nowadays, you would go to something like this. And you would probably, look, people have been forking the repository. Maybe you would set it to be watching. And then you would go in and just get involved with the issues. Just go start getting, you should be able to get into the discussions, and you should be able to find, typically there's two things we used to always do when we'd get involved with open source. We'd jump on if they had an IRC, and then we would jump on if they had a, like a mailing list. You want to be on the developer's mailing list, so you know what the pain points are. Nowadays, you can be in here tracking issues, right? People are just opening issues against stuff all the time. And sometimes issues get ignored. Sometimes issues get whatever, but people can drop stuff on there. So that's what I would do, Fractal. How do you navigate the code base? You would download it, right? You would clone it down, and then you would use whatever tool you want. I use VI Vim. You can use VS Code, right? VS Code is a perfect. So like my labs are all right here. I do all my Prolog labs under here, because it's easy to show you guys and it's easy to work on them. So if you're like, oh, I want to see about that Linux system checking lab that you have, this is all of our system checking lab right here on how you start out, and then this is how you finish it. This is the structure that's defined by Killer Coda for you to push stuff up there. And you guys could fork, yeah, I was going to say, you guys could fork my stuff and start your own competing Linux labs with all of the Prolog stuff that I have. I don't care, right? Like anybody can do that. That's one of the nice things about open source. And if I don't want you guys to be better than me, I just got to make my stuff better, right? And that's my goal. So, all right. Well, hopefully that's all clear. But yeah, you guys are welcome to just hang out. Like nobody's got to do anything. But if you want to, I tell you guys, one of the best things you can do is help the junior engineers, help the people that are struggling around the group. Don't smash them out until they want to leave the server, like sometimes happens. That's the worst thing we can do. We got to treat our new guys like friends, not food, right? All right. So PidStat shows us what's going on with the system, and it's just a nice. Where'd my PidStat go? That's a PidStat-L1, and this system's mostly sitting idle. The system's kind of chilling. But if I come over here and I pop a stress on here, right? I go back to like a stress 4. Now over here, I'll see stress really hammering my different CPUs over here. I can see what CPU it's on. I can see the process ID. I can see how much of the user space. It looks like it's split and it's using half and half. So the CPU is really under heavy load. Okay. And you got to remember this is per PID, so the CPU is being used 100%, but only so much by this one and only so much by this one, if that makes sense. What this one sees as idle is not truly idle because it's being used by one of the other ones. So, Yeah. So we can see. So let's just say you were using, you had a black box. One of the reasons I use Java as an example is it's one I've run into a lot. On the Linux side of things, I can't see what's going on inside of your JVM. So you're a Java developer and you're working with like a platform engineer like me, and you're like, Scott, my code doesn't work on your Linux boxes. It works on other Linux boxes, but it doesn't work on yours. And I go, all right, well let's dig in and look, and we say, okay, you're properly multi-threaded. I see you using more than one CPU and maybe up to what you expect. We only have 2 CPUs here, so that okay. So you're using all your CPUs, good. But maybe there's something that happens inside of your code that I can't see. Again, down here, I can't see what it's doing. I can only tell that it's not reaching out anymore. Maybe your JavaScript goes to sleep, or your Java code goes to sleep. Inside your JVM, maybe we start to see these not using any CPU anymore. Like our CPU, what would happen if nothing was running on this is PIDstat will just not show anything. So it just doesn't show anything for like 10 seconds. And then it starts showing stuff again. And then it stops showing stuff for like 10 seconds. Then it starts showing stuff again. And then you go, wait a minute, hold on. And then you say, I do know what that is. That is I have some, I thought I had taken that out, but that was maybe in some test subroutine you have or something. When some condition occurs, the system sleeps for 10 seconds to wait it off. And you're like, oh shit, I thought I was going to pull that out before production. But I can't see what's happened. Do you guys see what I'm saying? Like, I can't see the process calls that are happening inside of a JVM or anything. It's one of the frustrating things about Java virtual machines is everything's happening inside of it. So we're not seeing down at the system level. But what I do see is maybe it goes to sleep for 10 seconds. It's not doing any work. And then maybe that's a behavior that you had forgotten about. Boom. And I'm just making that up, but that's something similar to something I have seen before with a developer, and developers sometimes have, 20, 30 person teams, maybe even more. And then, when something went live, they didn't realize that there was some check that did something. And then there you go. So these are the kind of things that we might, learn about or deal with. So PIDstat will tell you what's kind of going on. So we can sit here, we can watch this. It's going to go for 240 seconds. So let's go to our next one over here. Oh, yeah. Also, it'll show you if it's using more CPU than is there. So now that is always going to be a saturation issue, right? Once you have 1591, that's a saturation issue, meaning you are above full utilization, meaning that you are waiting. Maybe inside your Java, there's something that when you touch test data, you had a test data set of 10,000. You never pushed anywhere near 15,091. You got to the real data of like 10 million users in real time. And now your Java is taking forever to do queries that did not take that long before. And now you're hitting timeouts. That's a possibility. But that's the thing that we got to be able to track. This is also very important for logging, right? I'm a big fan of looking at the logs and knowing what's coming out of a system. But I can't write that for you, right? I mean, I'm not a software engineer. If I was a software engineer, I could write that for myself, but I can't. I'm just the guy on the system side of things, watching the processes. Also, I know it's finished. Right. So, IOStat. IOStat's one of our buddies. IOStat is pretty much king too. So IOStat -C 1. Every 1 second, how's the system doing? And this is just going to be the aggregate average of everything. So this isn't as granular as the other stuff. So this is really just overall load and stress test of the entire system, right? It's not granular like MPstat or PIDstat were. But I used a -C. There's another one here that I love, which is D. And now we can look at how the devices are doing. So how are the devices doing in this environment? And the devices are, in this case, MD0. How are his reads and writes, his discards, and then this is his read and write per second, and then this is his overall read and write for whatever time. So, if you didn't know, stress test can also do disks. So I can come down here and say, I want to spin up X amount of workers that are just writing to my back-end disks, right? So I'm going to say stress excuse me, -D. By the way, we do this in one of the weeks of the Linux sysadmin course. We kind of do like a lighter version of this, but I just get you to kind of touch the tools and understand it. Let's say that we're going to pretend we have 4 disk drives. We do have multiple, but they'd be the ones that are mounted. So let's just run this, and we'll do a timeout of 180, so 3 minutes. We broke we broke the box, guys. All right, he's not down. We're gonna give him D1. IOStat. All right. By the way, there's a reason this isn't doing this, but it's actually, it's over here. What's actually happening is because this is everything's in tempfs, we're not writing back to those disks because they're not mounted right now. I forgot about these are just raw disks that we have sitting there. They're not mounted. So let's go run it on a box that is doing that. So we'll do this guy, we'll go -D4, and then we'll go 180. We won't crush him too hard. And then over here, we'll do iostat-C1, whoops, D1. So now we're gonna watch him spin up quite a bit on the disks. XVDA and DM0 are, XVDA is the raw disk. So that is the transactions per second that are happening to that system. The writes and the kilobits written, as well as the those are kilobytes, by the way. They're capital B bytes, right? Kempis, can I tell you that's one of my favorite questions that people ever ask me? I will show you. Yes, I will show you how that works. Hold on. Guys, he asked, how do I configure that splash screen? So, there's an ASCII generator. This is one of my favorite things to show you guys. So, boom, and boom. So this is for you guys on both sides, Twitch and YouTube. You guys should have that now. And you can just come in here and say that you wanted to call a box. Let's say you just wanted to call a box squishy. And you're going to call them squishy. All caps. And then you come here and you say test all. And it'll give you all the variations of ASCII art with squishy. There are so many of them, guys. And then I just would find a few that I like. And I think Ogre is one that I normally like because Ogre kind of looks nice. Look, little devils on there. And some of these look really good. Anyways, and then you just configure it as a message of the day. MOTD, Etsy MOTD. Oh, see, we're seeing this box spin up. Yeah, that's it. So that's the link right there. This guy wrote a little tool that'll write. Yeah, look, this is rectangles. That's clean. That looks pretty clean for like a high performance compute cluster. They're standard. Some of those might be a little too wide for some terminals, so I would try to keep it. No, the train's not bad, but I think it looks a little silly. We should be getting down to the ones that I normally like, right? Some of those are hard to look at, but some people like them. Hold on. But that's one of my favorite things to show you, yeah. And then you just go drop it in Etsy MOTD. There's Chunky Boy. And then Crawford. Yeah, some of those are okay. Yeah, and they'd probably look better on a black background. What options could I put it to a black background? All right. Anyway, so you could test all and just see all of them. It generates them on the fly too. So it'll generate any ones you want. So many. I think there's hundreds of them. I kind of like Ogre a lot of the times, but I don't really like that one. Maybe if we did lowercase. I like that one better. So lowercase with ogre. Yeah, I like lowercase ogre. It looks pretty good. Uppercase kind of look like garbage, but anyway, so there. That's hopefully that's good. Jump box. I have some configurations that I have up in Discord that'll show you how to do my jump box. The Bastion host setup that I run, I'm going to be teaching people in week 4 of the security engineering course, and should be there. So, all right, there we go. All right, so that's that guy. All right, the system's done reading and writing, but that's not the only way. So I might say, wait a minute, could I ls? So let's ls pwd ls-l. Let's see what's in here. Let's just make let's see how we're doing in this directory. du-sh dot. See how much space we have. All right, so we got some space. Let's do some not random, but like let's do this. Let's say while true do, and we're going to write a random file. Well, no, we won't write a random file. We'll write a bunch of zeros. So do dd in file is going to equal dev 0. So it doesn't use any processor. It's just going to pull zeros off the processor. Out file is going to be in this same directory. You can just use root and say big file, right? And the block size is going to be 1024K, and the count is going to equal 5,000. So it's going to be 5 gigs. Okay. After we do that, we're going to read that file. So we're going to dd. We're going to do in file equals root big file. Root big file. dd. And then we're going to throw it away. I guess we just put out file to dev null. We do it like that. All right. Then we're going to sleep for 5 seconds, and then we're going to do it again forever. Okay. So let's come back over here. Let's make sure this is still running. So we're watching that nothing's happening on the disk right now. Come over here. We're going to write to the disk 5 gigs, read from the disk 5 gigs, and then let's delete it. Yeah, that's good. All right. So start that process. Come over here. Now we start to see all the writes. Boom, massive amounts of writes, right? It's going to finish. We're going to get a massive amount of reads. So writes are going. Now reads are coming out. There's our reads. Done. Deleting. It's going to do all of our writes again. Actually, you know what? Hold on a second. Let's put a sleep in between there. Just so we can see the timing difference. So it's going to write, it'll sleep a little bit, it'll go to rest, let the potato rest, pull everything out. Or am I dumb? Well, you gotta start the shit. It's on a sleep right now. I was sitting there waiting for it, and I was like, why is it not doing anything? Oh, man. All right, hold on. It might be writing soon. Am I dumb? Could be dumb. There's our writes. It's building that file. That's transactions per second. So it's all done. Now it's going to read. Watch, it's going to read. Boom. Oh, no, it's writing right now. So it's writing. That should be reading. Low writes. Those are just some file system things. Now we should get the reads. Where's the reads? Come on. I have to have broken something. Oh, there's our writes. Should be writing out. Should stop, and that should read. 5 seconds later. I might be dumb. Let's go look. I should read. File dev 0 to write over block. Yep. Sleep for 5, and then it should read from there. Just read into memory. Drop it out. Sleep 5, and that should remove it. It should start up again. Hey, Verse Acorn, how's it going? Yeah, that is the the TPS is the total transactions per second to the devices, which what can happen is you can know what the theoretical limit is, or you can have a tested number that you know that's the highest your system can do. And then maybe you have 3 different processes that are trying to write on the same disk. And then you find that, you know, they go just over the top of the IOPS, and now you have some kind of problem. So, Doki, being late's fine. We're just going through some Linux stuff. We're just walking through Linux sysadmin stuff. So, I don't know why I'm being so dumb here. That should read in, that should sleep 5 and then remove it. That should start over. Alright, let's go check. Should be writing. Well, it was reading too. That's weird. Alright, so it should write. Then it should read. Nope, it's writing again. Should delete it. There's our first write. Apparently our second one's also behaving as a write, which is not what I would have thought. What's going to happen right here? It's going to be a write again. Yep. All right. I think here's the problem. It's the way I wrote it. So we're not going to go to an out file. We're going to just throw it away. That should dd in file equals that. Let's try that. So they should do our read, should do our write. Again, we should have still seen a read because it has to read that file out to be able to throw it away. So I would have thought we'd have seen a read right here. Very little reading. Okay, that's fine. Jack's playlist, fire 1 starters, because what should I watch? Yeah, so Doki, we have a Discord. Discord is, oops, let me get this out of here. Discord's free for anybody. And down in our Discord, who knows what's even going on in there anymore. But in our Discord, we have like a beginner start here section. So if you're like, hey, I want to learn all this stuff, but I don't know where to start. We've got a set of like my YouTubes that are just about like beginning Linux. And then we've got a bunch of certs you can go study that are free, that are just kind of related to Linux, but important. And then we have a Linux sysadmin course that's still in week 1 right now. We're still in week 1. You could start it. That's all here. And then it's also down here in Prolog projects, and it tells you how to start. There's a lot of people, if you ask questions down there, that'll tell you how to do this stuff. There's also a, set of questions for the new course. You can go read about those if you want. People asking questions down there. So there's a lot of stuff in the Discord, and the Discord's a lot more. It's a lot easier to get a hold of me down there because when I'm streaming, obviously I'm focused on this stuff and doing other stuff. But if you ask something in Discord, there's going to be a lot of people out there that can kind of help you. So, all right. Let's get back over here where we were on IOStat. And I just want to show you that IOStat can see what's going on with the disks. That's very important when we're dealing with, especially if we have like multipath disks and we want to make sure that the channel paths are going the way that we expect them to. IOStat-D can help you out. There's another version of the command in here that's also super useful. Let's just take this back to like C here. And, whoops, -C, let's do like C2. And I'll go over here. And then you can do iostat-xz1. And I like this one because what xz1 does, it's not intuitive, but watch this for a second. What this is going to do is it's going to show you, at the start, it shows you everything. It shows you the CPU load and all of the I/O of all the devices. Then, in each next step, if there's nothing there, it shows you nothing. So watch, this one's not doing, this device isn't doing anything. It's sitting here chilling. But if I were to come over here and run my stress over here, we would only see as the system starts to be used. If I had I/O to the disk or devices, we would see them here. Let's go watch it on this other system because this other system is more fun. Go here, and then iostat-xz1, and this will show everything, but now it's only showing things that are actually being used in real time. So I have, there's some CPU being used, there's some devices being used, they're mostly being used for writes down, and then here's the utilization of those disks. How utilized are those disks for reads and writes as a percentage? And then it's a little bit different output as the other ones, but it's all my writes per second and all my reads per second. So if I had disks in an array that were hot, I can go and look at, and when I say hot, I mean they're running hot. Maybe they're burning up and failing before their MTBF, which is your mean time between failures, right? Maybe they're failing more often than they should. We can come in here and see, are certain disks getting too much writes to them, and are certain disks getting too much reads from them? Do we need to rebalance the cluster of data and that kind of stuff? So there you go. Yeah, Doki, you're definitely welcome to hang out. Just come and hang out. Our goal of our group is to get you guys doing this stuff professionally. Most people that hang out with me for more than about 5 minutes probably do this in some amateur or, at least in some hobbyist type way. And then our goal is to make you guys able to do this stuff professionally, if that's what your goal is, right? Get you guys into a professional state. All right. So anyway, so that's that. We're just messing around with these. I can stop all these. Go back into Rocky 19 and let's keep going. These are different tools we have to observe the system. Then we have SAR. SAR is not synthetic aperture radar, but we can look at SAR-NDEV1. SAR can be used for so many good things, but I kind of like this one where it'll just show me how the interface is being used. How many packets are being transmitted, TX, how many are being received, RX. By the way, that is a generic networking and sending and receiving of data term that you will use everywhere as an engineer for the rest of your career. Sending is TX, transmit. RX is always receive. Okay. How much transmission kilobytes? And by the way, there's going to have to be some kind of translation here when you talk to your network engineers, because network engineers always care about kilobits per second. So you might have to do a little bit of translation, multiply something by 8, right? I'm looking at my loopback interface and my Ethernet 0. Those are my two interfaces, and then I see traffic that's kind of going on right here. We can spin up our system and see the load spin up as we send and receive packets. We can use iPerf or some tool like the iPerf 3 is the common tool for looking at traffic between a bunch of systems. So, all right, so SAR is good. You can also use SAR to see errors in the network. So let's say you were doing, here's TCP with SAR, all your TCP traffic, that's good traffic. And here's all your eTCP, which is bad TCP traffic. If there's any retransmits or errors or retransmit requests because things came out of order or a checksum didn't come in time or any of those kind of things. And you can look at them together. list. It shows up there. Maybe you just want to keep an eye on your traffic. Maybe you have, established set of, maybe here's what you might do. You might use a tool like K6 or Burp Suite and just do a bunch of connections to a web server maybe you're running on here. And that may be getting a lot of resets and connection errors and retransmits and stuff, and you just want to see it happen down here. And you go, okay, that's fine. You go look at your Burp Suite or your K6 tool, and you say, okay, what the hell is this thing that's causing load on my system? What is it seeing? And it sees that maybe all the certificates are failing to authenticate. So you're not getting HTTPS communication between your devices or something. But this may be a way that it would help you to maybe, or after a certain amount of time, you're getting, that TLS connection is busted, or there's something that's happening, and then maybe you find out that there's some interface that's flipping or resetting inside of the network and causing your system to take a different path. There's all kinds of things you might find out as you start to watch these things, right? So again, I would tell you guys most of the time to learn how to use these tools before you ever need them live, because it's going to show you stuff that's going on. All right. Yeah, if a destination server is overloaded or dropping packets. These are all important things to kind of watch the behavior and then learn them. So there you go. All right. So here's the observability tools that we just talked about for the Big Four. By the way, somebody's going to ask me, they always ask me, is this up on the Discord somewhere? This is on the Discord. This is called Linux Systems Administration. It's under presentations. And it's right. There's all kinds of presentations up here from different people. This one from me is Linux Systems Administration right here from May of last year. And I said, boom, I'm not a liar. And I put it up there. So there you go. So if you guys want to add to our list of emojis and download it, it's there for you to use. All right. But anyways, here's the observability tools for the Big Four. Utilization, saturation, and errors against CPU, memory, disk, and network. Those are all the things we just talked about. Because again, utilization, saturation, and errors will tell you how a system is being used. It will really help you to figure out what's going wrong in a system. And these are the tools that you might use to find those things. All right. All right. So, bunch of observability into a system. Things you want to know. Uname -R for the kernel. Uname -A for everything. Uname -M for just the architecture. Those are all important things to know how to do right there. Because, I've told you guys this, if you ever have to put in a ticket or submit something to like support, if you're not in the business of writing your own fixes, which most engineering teams are not, they're in the business of making it work the best it can for your company, you are probably going to have vendor support in some way, especially on government contracts. You have to have you have to have support if you're going to put any software in on a government contract. So if I say, hey, I'm having a problem with my Rocky 19 box, the first two things anybody's going to ask you is what's the kernel and what's the release version of the OS. So you grab these two things like that and you go throw them in the ticket. Now, you could just get away with the uname -A, but my point is I like uname -R because I sometimes want to compare. But what version of Rocky or Red Hat am I on? If I'm using Rocky or Red Hat. And then what version of the kernel? Those are the first two questions anybody asks on a trouble ticket. So if you're reaching out for support, there you go. How much memory do we have? We looked at that one already, so we don't have to probably do that one again. But free-m or catproc meminfo will tell you how much memory. How many processors do we have? You can use nproc. Pretty good one. Or you can cat proc CPU info for way more information than you would want. And then you could grep-i for proc. And then you could be too lazy to count it, so you can do that. Or you can just nproc. But the same basic thing that's happening. And you might say, well, that's really stupid, Scott. You only have the two. It was easy to count. Yeah, but sometimes I have systems with a lot. So that's way easier for me to count. And nproc, I have seen nproc be wrong before. I have seen nproc not actually count all the processors in the system. So feel free to do with that what you will. I don't know where it queries from, but I've seen it wrong before. So, and that was in the last few weeks. Was the first time that had ever happened. All right, you want to know physical disk information? LSBLK, what disks do I physically have? And BLK ID. This shows me the system disk, the UUID if there's a UUID for it, and other information. And one really, really important thing that's right here is if there's a file system on it. This one has an ext4 file system that somebody made probably a while ago. Right here. XVDA is type ext4. So there's data out there on that file system possibly that I can mount and get at. All right. We're not going to mount, well, we're not going to mount stuff right now, but I could. df-h, we don't see it. Mount dev xvda to mnt. CD to mnt, ls. Woohoo, somebody put a little test file in here. What's going on in there? Nothing. All right. But there's a little test file. And there he is. There's this guy mounted. Then I try to U-mount him. I can't because I'm in there. So then I CD back to root, and I can U-mount that drive. Not there anymore. Boom, gone. And we have a lab that teaches you guys about how the drives work. Like if you're in a directory, why you can't unmount it because there's open file system, like there's open processes using the file system, so you can't unmount it. You can look at the process hierarchy, ps-e forest. This shows you all kinds of stuff that is going on. Here's SSHD and information about that, all the way down to my PS command. I would probably throw an F on there as well, and then I can see everything, right? We take those process IDs and we can dig in, and we can see what that's doing. LSOF on this process would show me all the files that thing's open or touching. And is it listening to any? Yeah, here's its actual connection from Werewolf on 34448. That's the client port back from the Werewolf node that jumped into it. So, Amber, you just got to spend time with this stuff. I assure you guys, if you spend time with this, you'll get it. Just got to spend time with it. That's all it is. Just get in there, play with the system. Like, 10 minutes a day with the system, doing some of these tasks and different labs that I have, and there's all kinds of other labs online. Killer Coda is probably one of the best things on the web for getting you guys into a terminal. I have a bunch of Killer Coda labs, but there's all kinds of other ones. Just get you in and get you hands-on, right? Getting your fingers used to doing this stuff. Getting you used to looking at these types of connections and stuff so you know what's happening, okay? See if I'm missing anything over here in chat. All right, we're good on chat. I like this one. So we have SSHD. So when the system came up, systemd analyze blame, we can see what took the most time to come up in the system. It's one of my favorite commands. It just shows me DNF make cache.service took the longest time of all the processes. Followed closely behind this WW client service. A bunch of other stuff. We could also, let me show you this. We can do a systemd analyze critical chain for sshd.service. And we can see, oops, SSA critical. Did I spell critical wrong? Oh, I don't need my bad. Just like this. And this will tell me all the things that had to start for systemd to start, or systemd, for SSHD to start on the system. Here's all the things that came up in order to get to an SSHD service. So if SSHD wasn't running, if I went here and did systemctl or systemctl list units state equals failed. And by the way, somebody showed me the other day that I could just do this. And I'm like, well, that's no fun. But it's an easier command, I guess. So systemctl -- failed. These are all the things that failed to start when my system came up. It's a lot of stuff. I need to spend a little time making this system a little more ready to boot. 1, 2, 3, 4, 5, 6. So real quick, why might I care about this? What if I had a Rocky 18 and a Rocky 19, and I get to them in the middle of the night? Somebody calls me out and goes, "Hey Scott, 2 boxes rebooted. We know that. Rocky 19 not working. Rocky 18 is working." I go to Rocky 18 and there's none of these. I go to Rocky 19 and there's all of these. I go, can I start those up? Try to start them up. Breaks. It's very possible that maybe some of these services were trying to connect to something at the same time as the other one. If Rocky 19 is already busted, I might just reboot it again just to see. Just before I do anything, before I even start to rack my brain on all these other things. I know those 6 services failed on startup. So maybe, and the other box didn't. Rocky 18 didn't. So I might just go, I don't know why they rebooted. That's maybe a problem for Monday. Maybe somebody caused it. But maybe this box just needs to reboot first. So maybe we reboot it. Surely be released because AI making moves now. That's funny. Yeah, Amber, that's the goal of this, is to show you guys that you guys can do this stuff. Make you guys think about things that maybe you haven't done before and look at the system from like a lower level. Most of the stuff we've been doing is in Rocky, which is a Red Hat derivative, so it's very valuable for people that want to work in the Red Hat world. So, all right. So, why did they fail? We can go dig into why they failed and all that crap, but the point is we can see that they did fail. I didn't realize these many were failing. I'm going to have to go figure out some of this up. In fact, some of these are running, so that's weird that they're failed initially. So now I got to go figure that out. But maybe I go and I want to see how this system was called when it booted. So maybe as the system was booted up, it went through its iPXE process, pulled down its initramfs and its kernel, and then it started. And then when the kernel was done off the RAMFS, it switched over to switch root over to the actual hard drives, which are just in RAM on this box, but that's fine. This is all of the configurations that were started for this box to boot right here. These are all the command line calls that were called with this system. He was told to start a container that was found over here for his specific system. That's his container. Here's his system right here. A lot of information. Very weird. Very, very non-standard, this stuff right here. But in my containerized environment, this is very standard stuff. So I have to learn it. For somebody else, I would tell you don't worry about learning this stuff right off. But for somebody on a normal Linux box, learn what that might look like. That's what it might look like on a normal box. We're going to boot off of HD0 on the system. We're going to boot this kernel. We're going to tell it that there's its root. We're going to tell it that it's got crash kernel auto. And then we're going to tell it that it's got swap if it needs it. And then there's a logical volume management for root and logical volume management for swap right there. And then we'll start up in RHGB and quiet mode. Quiet mode we turn off a lot of times with servers when we are troubleshooting them, because quiet means just don't dump a lot to the PTY, like the terminal, the physical terminal, and we sometimes want all that dumped. So I'll do quiet when I want to see everything happen, and then, or I'll take quiet off when I want to see everything happen. There's no loud, it's just nothing or quiet. And then quiet also, yeah, it doesn't show you a bunch of other stuff. There's another option I love to put here if I'm using multipaths, like, and I have multipaths to maybe over the network to like tens of thousands of disks. There's one in here called fast boot that I use. LVM is logical volume management. Yeah, LVM. LVM. All right. Anyways, there's a bunch of those. And then here's some more observability stuff that we could just do on a box. And if you're doing it, uptime. Boom, boom, boom. Am I in loud mode? Yeah, loud mode instead of quiet mode, yeah. All right, so there's observability summary, a bunch of things that you could put in there. And then we get to like testing methodologies. And I'll show you guys a little bit about how I test things. I got to go look at some. I just got messages from a customer. I got to go look at them. But last week, we use recommended easy backup procedures when deploying new software. Scenario is always assume you were out all night drinking. It's 4 a.m. You just got called. How complicated a process do you want to get the service back up? Yeah. And honestly, before I ever touch a system, I make sure that I can redeploy it in dev. And then make sure that the process is ready to fire in prod. So, hey Vanny, how's it going? We are not working too hard today. Well, we're working a little harder. We're doing systems, Linux systems administration. And for people that got here late, let's do a quick rundown for people that got here late. We start up here. This is Linux systems administration, again, from May of last year. I'll probably update this again. But we talked about admin tasks. We talked about how we observe, benchmark, and tune. Then we talked about utilization, saturation, and errors on any one of the big four, CPU, memory, disk, network, in that order typically, right? Then we talked about uptime, VMstat, MPstat, PIDstat, IOstat, SAR. We talked about BrendanGregg.com, where he's got these awesome, all these other things that you could want to dig in on, right? Here's our user observability for the big four, and there's more information. And then this is up in the Discord if you guys need it. That's your quick rundown. Some other commands to just do, because again, touching a command and kind of holding it in your hand and seeing how it works is valuable, right? So then the next thing we were going to do was testing. So give me a second real quick. I'm going to take a walk again real quick. Pull up another hourglass. If anybody wants to hang out and do, let's say, break and take a walk. All right, I'll be back. I think the wife's coming home soon, so I only got a little bit longer. But I will be here. I'll be back. All right, we're still on break, guys. But I do have a very important question. Ow! To ask you guys. My knee hurt. I just popped my knee. Okay. Very important question to ask you guys while we're still on break. Should I do more networking here? Full well, no, not right now, but I mean in general. Full well knowing that I just got asked, what do we look for high performance compute guys? I just got asked that in the Discord. So, well, it was for sysadmins, but the job is for HPC admins, so I guess that's what they're asking for. So, you need to know Linux well. And then you need to know networking and security, I would say, at least some. But I would say you need to know Linux well. And you would need to probably have at least one automation tool pretty well down for that. So I was just asked about that because I had a job posting in the Discord for my company. And people were like, well, what does it take to be a senior HPC engineer, right? Because that's what senior HPC admin, they call them. But, yeah, so I would say you need to know Linux really well. And then you need to be pretty good with networking, probably back-end storage. It'd be good to have worked with that stuff. To be a senior, they're going to want that to be for a few years for sure. And then you have to be able to demonstrate it all, talk to it, that kind of stuff. Which I can give people a lot of information to be juniors. I can give you guys a lot of stuff to practice to be ready to be a junior. It's hard to get senior positions without experience, unfortunately. But I don't control any of that, right? I'm not the guy hiring. In fact, I'm probably not even going to be the guy interviewing on those. They might ask me to interview, but I do so much yelling at people that they don't. No, I'm just kidding. All right. 2 more minutes on your break. I'm going to sit here and sip my water nice and slow. If you guys want to talk about some testing, this gets into like testing and benchmarking a little bit. We'll talk a little bit about that stuff. And then I'll probably get off here. I think the wife's coming home soon. So, could have been missing phone calls too. They text when my buddy's back. Huh. That's fair. Yep. All right. We'll get back here in the systems in a minute. Break, take a walk, smoke them if you got them. That's what they used to say in the military. I never smoked, but never been my thing. All right. Oh, it also looks like we're on an ad break, so that's probably good. We'll wait until the end of the ad break on the Twitch side of things. And that pretty much just lines up with all this stuff too, so then we'll go. Jones, I just go to the data centers that the customers are at. This was a data center called Aligned. I think Aligned has a few different data centers around the country. They're fine. Yeah. Well, the alpaca, I would probably super addicted to nicotine because my family all was. So, yeah, I don't need any nicotine. I already have a caffeine addiction, right? So, all right, let's get rid of this. All right, so let's talk. This will be a little more in the abstract around the testing methodologies that we use, right? So, as engineers, if we're asked to do any of those things that we saw earlier, we would develop a testing methodology around it, right? A way to prove that the system is or isn't behaving the way that we expect it to, or whatever. But we gotta do it with numbers, right? We gotta get numbers. We gotta gather them. So started when you were 14, quit over 6 months ago, and cravings never subsided. Yeah, Arth Vader, I have a family member who quit. He probably smoked for 30 years, and then he probably quit about 20 years ago. And to this day, he still always keeps a toothpick in his mouth so that he doesn't. This guy, I've never seen this guy in the last 20 years without a toothpick. He's one of my uncles because he can't quit. Yeah, he can't quit the wanting like nicotine. He said he's always going to want it. So he just has something always near his mouth for that. But he smoked. He was a gambler. He was all that stuff. But then he took him a long time. Yeah. So, Bind Magnus. Hopefully this stuff's, or BN Magnus. Hopefully this stuff's useful to you. Let's keep going. So here's my testing methodology. This is what I do when I do a testing outline. I try to think about what I'm doing. But all tests seek to record accurate information. We know that. We don't want to record bad stuff or useless stuff, and we need to record stuff that works the way that we expect it to, and all that. So we need a good testing methodology to ensure accuracy of information. We want to scope down. I was talking about earlier, like if you're revving up the system but you're looking at the wrong thing, that's not going to help you any. You need to collect it, you need to store it, maybe you need to aggregate it over time, maybe you got to put it in a time series database, and then you need to have controls of that data collection. Maybe you're collecting it over the same time frame. You're doing what we call ceteris paribus, which means that's ceteris paribus. That's better. And it's the idea that we keep things all equal as much as we can when we test individual type components, right? So we write up a purpose. Why are we doing the test? We want to prove that Rocky is behaving similar. Maybe we want to verify that Rocky is behaving similar to Rocky 18 and Rocky 19 are behaving similar, right? So now we go to both of the nodes and maybe we run an uptime. That's only one data point. That's not super great. So maybe we figure out that we want to run a certain amount of uptimes over the course of an hour or something, right? Maybe we even think of a better way to gather data. Whatever it is, we use Node Exporter to pull it out to Prometheus. I don't care what we're doing, but the point is, what are we going to test? Scope. How are we conducting the test and what is captured? We want to see load average on the system. We want to track load average. The Alpaca, have you used some sort of template to build out testing ideas so you can follow similar structure of reporting on tests? I guess that might sound, but yeah, absolutely. So I even have some. I don't have any in here. In one of my other things, I actually draw out like. I really didn't put it in here. Hold on. Hold on a second. Let me go grab it. I think I did it in the Linux sysadmin course. It's monitoring. Yeah, I just have something like this, like some basic little thing. This is Are the Things Doing? Yeah, so I have, like, I'll build sometimes like rapid prototype, so rapid recovery type stuff, and I have checks that'll go out and check systems to make sure that they're stable before I start another thing. Some of that stuff's automated in the system. Some of those things automatically trigger when the next one kicks off when we're bringing stuff back up. Yeah, I write startup procedures pretty often for big stuff. So, and what I do is I rough it out in my head, like this is how we power on the racks, and these are the things, and then these are the systems we touch first to get the storage online once the networking's all up. And yeah, I have all these things that I kind of do, the Alpaca. So, but yeah, that was like an example of a little small one that I might use for testing. All right, sorry, so here. And then what's in scope? If we're going to define what's in scope, we always need to define what's out of scope. What are we not capturing? What do we acknowledge but we're not recording? Like, we acknowledge that maybe disk is running high, but we don't expect to go over the top of disk, so we don't think that that's really that important. If an anomaly occurs, is it something that we do not consider? So if we are looking at a stack of data, we're looking at something like this, and we're seeing high CPU, but that's between like 3:14 a.m. and 7 a.m. and we know why it's high like that. Do we take all of these times and take them out of our actual load average of our servers and say, well, if we were to add those in, our load average of our servers would be like 25%. But since we know what those are and we are not using them as part of the calculation during maybe normal working hours are this time here, maybe this becomes like our normal working hours of the day, and then our average for that is only like 6 or 7%, maybe not even that, right? Oh shit, that might not even be 1% average. But the point is, how do we look at the system? What do we acknowledge? And I always tell you guys, when you look at stuff, as long as you're acknowledging, as long as you're kind of like looking at it in the face and not just like, I'm not going to worry about that data and hope nobody looks at it either. Somebody's going to catch it. Auditors are going to catch shit. That's literally all an auditor does. Like a person who decided to be an auditor is the type of person that loves to go, gaha, gaha. That's the personality that became an auditor. That's the person that did it for any more than 10 minutes, right? That's their personality. So they're going to find stuff. Shouldn't try to hide it. You should just accept it, look it in the face, and then that's also true of engineering. Like, you can't get around a limitation of a system. You can't get around a hard stop in a system. So you might as well acknowledge it and then work with it, right? So, okay. Our methodology, a description of how we will work to objectively determine quality of outcomes. Are we using qualitative or quantitative results? And what normalization points are we using? Are we percentage? Are we, there's 5 things that it could be, so we make them, a histogram or something like that. What are we doing, right? And then what's our control? What will be put in place to ensure that the collection is done against a similar environment between different systems? That kind of stuff. Audit this. I asked one of our guys in our Discord. One of our guys in the Discord has been a friend of mine for a long time. And I asked him one time, I said, hey, aren't you like a, because I had already gotten my CISSP. And I said, hey, you got like a CISA or something like that? Or don't you have one of those CIS? And he goes, I'm not a CISA, I'm a CISM, which is Computer Information Systems Manager versus the Computer Information Systems Auditor. And he goes, I can't be an auditor. I knew my father, right? He loves to say that, so if you know your father, you're not a bastard, right? So his thing is that he's not a bastard. I always thought that was a funny way to put it. He's like, I'd respond to you for that, but I knew my father. But that's one thing he said to me. He's like, yeah, I'm not a CISA. What the hell are you talking about? I knew my dad. All right. Big Bazooka over on YouTube. How's it going? We're just working through Linux Systems Administration. I got down to testing. I thought I had my testing stuff in this talk, but apparently I don't. It's over in week, whatever that was. That's unit 12 of the course, which means, hold on, it may be in the book. Let's go look in the book real quick. I can actually give you guys a page if that's the case. Go here. It's in unit 12. So if they're done with it, they're not done with everything yet. Well, I got some of it in here. Yeah. That's some data stuff. Biostat, yeah, lab stuff. Go and look at the lab. Yeah. So here's the stuff. There's a table. You can gather some tables. Yeah. So there you go. If you want that stuff, here you go. Boom. That book's free, by the way. Like, the guys just make it. Yeah, Big Bazooka. Thanks for that. Yeah, I try to be informative. I try to show you guys things that I either learned the hard way or just learned over time. Some of this stuff I picked up in a master's program for business. Some of the stuff I picked up, we pick this stuff up everywhere, and I just try to make it hopefully useful to you guys. So let me see if I can get my stupid, doesn't look like my thing's working very well. I could put my light up and then it would like standardize the background, but it's fine. All right, let's get that out of the way. Let's finish this up. We're almost done with this talk. This one's kind of a, testing outline, benchmarking. So we get into benchmarking. And benchmarking and baselining are terms that some people like to use interchangeably, but I have a way that I like to level set when I teach or show it. Baselining to me is like the low water mark. Like, how does the system behave in the wild? How does it just work day in and day out? That's kind of the baseline to me. And then benchmarking is when I step on the gas and I rev the system up, and I see like load test on the system. Can the system take 5,000 connections? Can it take that 5,000 and first connection? That's kind of my that's also what we call the difference between, well, not exactly, but when we spin a system up, that is benchmarking, but some people will call it load testing, or what we call non-functional testing. So functional testing is, it's a server, it's serving web, HTML on port 80. It is locked down on all the other ports, and I can SSH into it. Boom, check, 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 check. Those are all things I can prove. How it functions, so that's functional testing. Non-functional testing is, well, if I have 3,000 connections to the server running for more than 4 hours, does it take a 3,001st connection? Or is there something wrong with that? Does it break? All these kind of things. Tululope, I don't know how to say that. I hope that's right. Over on YouTube said, is there a course to learn Linux sysadmin? Yeah, we have a course running right now in our Discord for free. All you got to do is hop down in there and get involved. I think there's about 120 people in it right now. It's free. Doesn't cost anything. 117 it says right now. And then there's 89 in the security engineering course. I highly recommend people start with the Linux sysadmin course. And that time will be in your local time if you go down into there. So, yeah, so go get involved if you guys want. The Discord's got all kinds of information. If you get overwhelmed, go to Beginner Start Here. Beginner Start Here will show you, at the bare minimum, just getting your hands on a system, right? Get down in killer code to do all that stuff. All right, let me get this out of the way. So, here's our benchmark methodology, right? So we do a plan phase, we get goal identification, what tools and metrics are we going to use for the system, what are we going to pull out? Then we'll plan and resource allocation. We'll do some changes. Maybe we'll add a new disk array to a SAN. We'll do whatever execution and then get the results, and we'll test. What we do is we test the delta. So I've got a system that's running at, I don't know, it can every client can write at 2 terabytes a second. It's pretty fast. But let's say they can write at 2 terabytes a second. The bytes, by the way, not bits, terabytes. And they're writing into like a Lustre cluster. Bam, just writing data. And then I make some change. And that 2 terabytes per client drops to like 1.8 terabytes per client. Well, the treatment or the change that I made is likely what caused that, because we did everything else, the ceteris paribus, we made everything else the same. So now we say, okay, let's change it back. Do we get that performance back? Yes. And then maybe we say, well, that was not a good change. We shouldn't do that change. And sometimes we'll do this on like a microcosm and we'll see an improvement. But then when we get to real data sets, we don't see that improvement anymore. This is the thing. This is how testing occurs. We try to make our testing blast radius as small as possible so that we get good information. But there's nothing that'll break everything you do like prod. Prod is just a different data set, more information, just, yeah. There's a lot of stuff there. The Discord, by the way, if you need the Discord, it's on the YouTube side. It's down in the, I think description has it down there. So, okay. So this is benchmarking methodology. You do a report. Did we improve? Did we not? How do we improve? Do we go back? Do we have to roll back because we did not get the results we want? Or we monitor the improvement to make sure that it's solidified, and then we go back into our benchmarking again. And this is a way to do iterations through benchmarking. And I think that this needs, you have to have a level of maturity in your organization to do this. You have to be able to build systems the same way repeatably first. That's a first thing. So get a tool like Packer or Terraform or Ansible, whatever tool you want to build and deploy systems the same way. Then make changes, verify that the changes are good or aren't, okay? All right, let's come down here. Here's some benchmarking with iPerf just to see the speed of the systems, right? iPerf 3 will let you have to turn one server on as the client and one server on as the server, and then you're able to connect in. I need to get ready for a college class here in a little bit, but I don't need to hop in there just yet. All right, and then perf will show you. So perf is a command. You can do like perf stat for like PWD. Oh, I don't have perf. So DNF what provides perf. Let's see if it can find perf in my system. Oh, we just do. So we DNF install perf. Yes. And these are the things it's going to install or update. And then I just run my perf stat pwd. And it shows me, as I did a pwd command with no arguments, I didn't give any arguments to it. So the default argument that was used was the directory that I was in. Well, it gave me the output of that. Right, and then it tells me what it did. How long did it use the CPU? Did it go and it do anything? That kind of stuff. Now that's okay, but what if I did something like this? What if I did a perf stat for maybe curl www.google.com? I think that'll work. Let's just try this like this maybe. All right. So what happened here? Gave me the output. Told me what the curl did. Maybe I'll just do a summary for my curl. It gives me my output. Come down here. How long did it take? Took about 1/10 of a second to go do that. There were context switches. There were page faults. There were CPU migrations. Anything like that that happened. And if there were any kind of problems, I could go and dig in on those, right? So this might not be the only tool, but it could at least let you know if there's things that you didn't expect happening. Right? I didn't know there were page faults happening. Maybe I go figure out what was going on with it, right? Maybe I'm developing stuff and I want to see how the C code that I just compiled behaves. Perf stat will help you do that. There's other perf commands too, but it will help you to do some benchmarking on the system. So I can do perf stat on sleep. Let's say like sleep 5. So the system's just going to sit here for 5 seconds because that's what it does. And then we're going to see how it performed. There were 78 page faults while it slept. Okay, I don't know what that means, but I could go dig in, right? These are, I tell you guys all the time, if the command just works, you never dig in. But if there's a problem with it, then we go and use a tool like perf to go dig into what the command was doing. So let's do one other one. Let's do perf stat lsof dash maybe I 22. And maybe it tells us, here's all the things that are using and listening on port 22 in my system. Here's all the process IDs that are associated with it. Anything that's touching that file descriptor for TCP with port 22. And then here's the information as I read it. Here's the information about that read. Yeah. So this might be useful. It might not be useful. Go find page and blame it. That's I like that. Okay. So anyways, there's tools that'll help you figure out what's going on in the system. We could use stress. You guys saw me doing stress a lot. You guys saw me doing DD earlier, but I was DDing with 0. If I want to stress test the CPU, I use urandom. Urandom will pull either 0 or 1 off the CPU, and the CPU has to generate it. With random, it'll generate it with only when there's entropy, and urandom will generate it with or without entropy. And I'll let you guys go read about that because there's some interesting things that happen when you do or don't use entropy. And one of our guys that came and talked, he's actually the CEO of his company now, but he was a tech guy up until January. When he came and talked to us, he explained a story about how they were using random instead of urandom, and it was causing these VMs to take like 10 minutes to come up, and it didn't make any sense. But because random needs entropy and nothing was happening yet. So it's kind of an interesting. Okay, good. All right. Benchmark tools, again, read and write speeds. You can test speeds. Here's how that file works. Again, this is all up in the Discord. Benchmark tools, you can read out of a file system, see how fast it reads. And then here was some of our benchmarking practical application. Gather current information, make your change, gather the new information, compare the delta. If it's just a little faster or just a little slower, if that's what you expect, hey, I got a 6% improvement. From reading the documentation, I had been hoping for an 11% improvement. 6.5% is pretty good. Hopefully after the rebalance, we'll retest and maybe we'll get a little bit better output. That's that's the kind of thing that we might write up as we do some kind of effort in a system. And I think I told you guys about this. I used to run high performance compute for a company called Keras, and they had bought they were leasing a big IBM system. It was X amount of thousands of dollars a month, and we had a back end disk platform, and I had hot, medium, and cold tape. So the hot was SSDs. The medium was way more dense. I got about 10 times the amount of space as I did up in the hot. But I also had so many disks in my RAID 6, which was a RAID 6 8+2 array, which means 10 disks, 8 of them are in, 2 of them are out, and 2 of them are acting as hot swappable, right? So anyway, so we're running this, right? I'm running this array, and they go, well, Scott, hey, we need more space, so we're going to add just this mid-tier storage, this warm storage. And what we want you to do is test the overall speed of the system as you write to the mid-tier storage. And do we get enough speed to justify just using this and not using the SSD anymore? Because the SSD was so expensive. It was like 5 times as expensive to get this hot stuff. But in our use case and in our testing, we found we really didn't need it. It was just sold as like a package, hot, medium. So what we did was, in the future, we bought like 3 more packs of these disks. I want to say it was like 20 or 30 disks. We even bought another array. And every time I tested and showed that we were getting increased performance of read and writes across the system, our rebalances were better. Everything was better, and we were just going to scale that up. And we eventually decommissioned the hot. We didn't even need the hot anymore. The medium was so big. It was like you have so much space for activities, and with testing to prove, we were getting increased performance every time, and we didn't need that other stuff anymore. So we went to just basically like a medium and it was hot, like hot, I guess, medium and cold, and it basically was just a medium and a cold system after that. And tapes were really just used for off-site activities. So we ended up using tapes in a different way than they originally sold them to. But here's the thing: in all my changes, I always had the proof of, this is how the system will behave better. And I proved it every time, so then we used it. So, but if you're just guessing, I feel like this is faster. Somebody eventually one day is going to go, well, I feel like that's going to cost a lot of money. In fact, here's exactly how much it's going to cost us. You better be able to prove it's going to actually speed something up. So, and, I never had to tie that back directly to how much we made, but, I don't want to I don't want to put anybody's business out there, but I can tell you what they leased that system for each month was about the cost of a Lexus at the time. And every time they ran one of the 600 gene panels for a person, they made, I think it was about 1/10 of it. So after every 10 people, they paid for that system. We could run about 100 people a day through that. So it was a pretty good value, right? How fast we got that thing working. So, all right. Anyways, yeah, they were making their. It was almost better than like a bar. If you ever look at how a bar makes money, they make a lot of money off their alcohol. It only takes 3 shots to pay for a bottle of alcohol, right? And then there's at least another 18 shots in a bottle, right? Anyways, all right. Troubleshooting. You guys know. You guys have been through my troubleshooting stuff. If you haven't been before, it's all up there. We've walked through it. I have some stuff where we talk about it. I also think it's Unit 11 if you want to go watch the talk for Unit 11. So that's our troubleshooting section. All right, if you got questions, drop them in Discord. I'm going to get off here because I hear the wife's home. I appreciate you guys coming. If you guys hop down in the Discord, you're always welcome to just hang out down there and talk shop with people. There's a lot of good information. In the Discord, I've kind of built a special ability over the years of finding engineers that are better than myself and working with them. So we'll just drop off of here. No, I'll find somebody to raid on Twitch. Hold on a second. Let's go find somebody to raid. Let's find somebody to raid. Who's on right now? Let's go raid. Man, there's nobody doing tech stuff. Nobody that I know doing tech stuff. So we'll go raid over to Running Man. So I appreciate you guys coming by, and I will talk to some of you guys later on this week. All right. Take care.